The desert air is cold at night. Most people don't know that. They picture Egypt as endlessly hot, but when the sun disappears behind the plateau, the temperature drops fast. A modern structural engineer stands alone in that cold, facing the Great Pyramid. In his hand, a calculator. In his mind, a problem he can't solve. He's been trying for hours. The numbers refuse to cooperate. The pyramid's base covers 13 acres, and each side measures within inches of perfect alignment to true north. Not magnetic north, true north. The four sides deviate from equal length by less than 2 inches across a base measuring over 750 feet. His calculator tells him this level of precision, across such massive scale, shouldn't be possible without laser guidance systems and satellite positioning. But he's standing in front of it. It exists. It was built 4,500 years ago. The engineer runs the calculations again. The ratio of the pyramid's perimeter to its height equals 2 times pi. The slope angle relates to the golden ratio. The structure encodes the proportions of Earth's northern hemisphere. These aren't approximations. These are precise mathematical relationships embedded in 2.5 million blocks of limestone and granite, each weighing multiple tons, fitted together so tightly that a razor blade can't slip between them. He closes his eyes, opens them. The pyramid is still there, impossible and real. This is where our story begins. Not with answers, but with a question that keeps appearing the more we look at the ancient world. How did they know? The standard explanation involves copper chisels, wooden ramps, and thousands of workers pulling stones with rope. It sounds reasonable until you actually try to do the math, until you stand where this engineer stands and confront the gap between what we're told was possible and what clearly exists. Something doesn't add up, and that something might be more significant than we've been allowed to believe. For generations, we've been taught that human history follows a simple path. Primitive ancestors gradually developed tools and knowledge, building toward the technological civilization we inhabit today. Every history textbook shows the same progression. Stone Age, Bronze Age, Iron Age, ascending in a straight line toward modernity. We're told that ancient peoples were less capable, less intelligent, working with limited understanding of mathematics, astronomy, and engineering. But what if that story is incomplete? What if it's not just incomplete? What if it's backwards? The evidence keeps accumulating in ways that don't fit the narrative. Ancient structures displaying precision that modern builders struggle to replicate. Mathematical constants encoded in monuments built before those constants were supposedly discovered. Astronomical knowledge that required centuries of careful observation. Technologies that appear, flourish, then vanish from the historical record as if they never existed. The engineer finally puts his calculator away. He knows what the numbers say. They say that whoever built this structure understood principles of mathematics, engineering, and astronomy at a level we associate with much later periods of human development. Either our timeline is wrong, or our understanding of ancient capabilities is fundamentally flawed. There's a third possibility, one that's harder to accept. Perhaps human history isn't a straight line of progress. Perhaps it's a cycle. Civilizations rise, achieve remarkable heights of knowledge and capability, then fall. The knowledge scatters, fragments, survives in pieces, in myths, in monuments, in traditions that preserve techniques without explaining why they work. Then, centuries or millennia later, we rediscover what was once common understanding and congratulate ourselves on our innovation. What if everything we learned about ancient history was designed to hide the most important truth, that they knew things we're only now beginning to remember? The pyramid stands in the darkness, keeping its secrets. But around the world, in structures both famous and forgotten, those secrets are encoded in stone. Waiting. They've been waiting a very long time. In 1901, divers searching for sponges off the Greek island of Antikythera discovered something that shouldn't exist. Encrusted in coral and bronze corrosion sat a mechanism with dozens of interlocking gears. For decades, it remained a curiosity, its true nature hidden beneath centuries of decay. Then came X-ray technology. The scans revealed a device of staggering complexity. The Antikythera mechanism contains at least 30 bronze gears working in precise harmony. It predicted astronomical positions, the movements of the sun, moon, and planets through the zodiac. It calculated lunar phases and eclipse cycles. The gear work is so sophisticated, so precisely calibrated, that nothing comparable, appears in the historical record for another 1400 years. We're told it was built around 100 BCE, during a period when humanity supposedly worked with basic tools and primitive mathematics. Modern clockmakers who've studied the device express quiet disbelief. The gear teeth are cut with accuracy measured in fractions of millimeters. The differential gearing, a complex mechanical principle, appears fully developed, not as an early experiment, but as mature technology. This wasn't someone's first attempt. This was the product of a long tradition of mechanical engineering that left almost no other trace. Halfway around the world, in the highlands of Bolivia, sits another impossibility: Puma Punku. At 13,000 feet elevation, massive andesite blocks lie scattered across the landscape. Andesite ranks near 7 on the Mohs hardness scale. Modern construction uses diamond-tipped tools to work it. The blocks at Puma Punku feature cuts that look machine-made, perfectly straight edges, 90-degree angles exact to within fractions of a degree, surfaces polished smooth as glass. The H-blocks present the deepest puzzle. These aren't simple rectangles. They're three-dimensional jigsaw pieces, with complex notches and protrusions that interlock with neighboring blocks. The tolerances, the gap between fitted pieces, measure less than 1 millimeter. In some places, there's no gap at all. Stone against stone, fitted so precisely that you can't slide paper between them. Modern machinists admit they couldn't replicate these cuts with current technology. So how did people 2,000 years ago do it with copper chisels? The standard explanation involves time and patience. Given enough decades, enough workers, enough trial and error, anything is possible. But that explanation works better in theory than practice. Cutting andesite with copper requires more than patience. It requires copper harder than andesite itself, which violates basic materials science. Or it requires abrasive techniques so sophisticated they would themselves indicate advanced knowledge. The precision appears elsewhere, in forms both large and small. In Costa Rica, nearly perfect granite spheres dot the landscape. Some measure 8 feet in diameter, weighing 16 tons. They're spherical to within centimeters, an achievement requiring mathematical understanding of three-dimensional geometry and manufacturing techniques to match the theory. In Egypt, ancient stoneworkers carved vessels from diorite, a stone nearly as hard as diamond. The vessels feature delicate handles, narrow necks, and walls so thin they're nearly translucent. No tool marks remain to show how it was done. Then there's the Baghdad battery. A clay jar, a copper cylinder, an iron rod. Fill it with acidic liquid, and it generates electrical current. This shouldn't exist in 250 BCE. Electricity wasn't discovered until the 18th century, we're told. Yet replicas work perfectly, producing measurable voltage. Archaeologists call it a container for scrolls, but that explanation requires ignoring its obvious function. Each example stands alone as an anomaly. Together, they form a pattern of capability that doesn't match the tools supposedly available. A pattern of knowledge that shouldn't exist in the time periods we've assigned to these objects. The precision is undeniable. It's measurable, photographable, quantifiable. What remains mysterious is the method. But precision alone isn't enough. Creating these objects required more than knowledge and skill. It required energy. Power to cut stone, to melt metal, to transport massive blocks across impossible distances. What energy sources did they harness that we've forgotten? The evidence exists. It sits in museums, stands in archaeological sites, fills academic papers tucked away in specialized journals. So why doesn't it change the textbooks? Why do high school students still learn that ancient peoples were primitive, limited by crude tools and simple understanding? The answer isn't a conspiracy in the traditional sense. It's something more subtle and perhaps more powerful. Academia operates on consensus. Researchers build careers on established frameworks. A young archaeologist who challenges accepted dating methods or suggests advanced ancient capabilities faces a choice: conform or find another profession. It's not that evidence gets suppressed through sinister meetings in shadowed rooms. It's that the system itself filters out information that doesn't fit. Funding flows toward research that confirms existing theories. Publications favor papers that build incrementally on accepted knowledge rather than questioning foundational assumptions. This phenomenon has a name: paradigm paralysis. When an entire field becomes invested in a particular worldview, contradictory evidence stops being seen as an exciting mystery and starts being viewed as a threat. The anomalies we've discussed, the Antikythera mechanism, the precision at Puma Punku, the Baghdad battery, each one gets explained away, reinterpreted, or simply ignored, because acknowledging them would require rebuilding our entire understanding of human history from the ground up. But there's another layer to this mystery. Perhaps some of this knowledge was never meant to be public in the first place. Ancient civilizations didn't operate like modern democracies with universal education. Knowledge was power, and power was guarded carefully. Mystery schools in Egypt, Greece, and Mesopotamia operated on initiatory systems. You didn't learn secrets by reading books. You underwent years or decades of training, proving your worthiness, advancing through levels of understanding that were never written down. The most important knowledge traveled through oral tradition, master to student, protected by oaths of silence so sacred that initiates chose death over revealing what they'd learned. This system meant that when a civilization collapsed, its highest knowledge often died with the priests and masters who held it. What we call lost technology might actually be restricted technology, advanced understanding deliberately kept from the general population, and therefore vulnerable to extinction when those elite circles were destroyed. History provides endless examples of deliberate knowledge destruction. The Library of Alexandria burned, taking with it hundreds of thousands of scrolls containing ancient wisdom we can barely imagine. When Spanish conquistadors swept through the Americas, they systematically destroyed Mayan codices, Aztec astronomical records, and Incan engineering documentation. Catholic priests burned books they deemed heretical, erasing entire intellectual traditions. In China, the first emperor burned scholars and books to consolidate ideological control. Each instance erased not just information, but entire ways of thinking about the world. What survived often did so by accident. A ship sinks with the Antikythera mechanism aboard, preserving it in conditions that prevent complete corrosion. Massive stone structures prove too large to dismantle, so they endure while the knowledge of their construction vanishes. Oral traditions persist in fragments, their original meaning obscured, but their formulas intact, waiting for someone to recognize what they actually describe. What if the reason we don't learn this in school isn't because it's false, but because it undermines the entire story we've been told about human progress? The narrative of steady advancement from primitive to sophisticated is comforting. It suggests we're at the pinnacle, that history was building toward us. Acknowledging that ancient peoples possessed knowledge we're only now rediscovering requires humility that institutions don't easily embrace. So we're left with fragments, mechanisms that shouldn't exist, precision that shouldn't be possible, technologies that appear and vanish, and questions that rarely get asked in academic settings, but echo through the minds of anyone who looks closely at what remains. We're not just exploring what the ancients knew. We're uncovering why that knowledge was hidden, how it was lost, and what pieces survived despite everything working against their preservation. The journey ahead takes us into specific domains where ancient mastery becomes undeniable. We begin with something that exists all around us, yet remains invisible until we learn to recognize its power, sound itself. In the 1,990 seconds, researchers entered the hypogeum of Hal Saflieni in Malta, carrying unusual equipment. Not the typical archaeological tools, but sound generators and frequency meters. The hypogeum is a massive underground structure carved from solid limestone around 3,600 BCE. Officially, it's a temple, but these researchers suspected it might be something else entirely. They began testing frequencies, sending different sound waves through the carved chambers. At 110 Hz, something extraordinary happened. The entire structure began to resonate. Not just vibrating, the stone itself seemed to come alive, humming with a deep, penetrating tone that participants described as feeling rather than hearing. People standing in the main chamber reported physical sensations, tingling in their bones, pressure in their chests, a strange sense of altered awareness. The researchers documented everything. Later analysis revealed something that shouldn't surprise us, but somehow does. 110 Hz affects human brain activity in measurable ways. Specifically, it influences the prefrontal cortex, the region associated with language processing, decision-making, and self-awareness. At this frequency, brain activity shifts. Neural patterns associated with normal waking consciousness decrease, while patterns linked to meditation and trance states increase. The hypogeum wasn't alone. Once researchers knew what to look for, they found it everywhere. In Egypt, the king's chamber inside the Great Pyramid contains a massive granite coffer. Strike it correctly and it rings at F-sharp, resonating through the chamber with extraordinary clarity. The chamber's dimensions create standing wave patterns at specific frequencies. Sound doesn't just bounce around randomly, it forms organized patterns, nodes and antinodes that acoustic engineers recognize as intentional design. The granite itself, with its high quartz content, responds to acoustic pressure in ways limestone doesn't. Quartz is piezoelectric, generating tiny electrical charges when compressed by sound waves. At Stonehenge, acoustic measurements reveal that the stone circle originally would have created a sound environment unlike anything in the natural landscape. The bluestones, transported from Wales across incredible distances, have acoustic properties different from local stone. When struck, they ring like bells. The circle's geometry focuses sound inward, creating an acoustic mirror that amplifies and sustains tones produced within the structure. Newgrange in Ireland shows similar sophistication. The passage tomb's interior chamber is shaped to create powerful resonance at specific frequencies. During winter solstice, when sunlight penetrates the chamber, researchers have recorded unusual acoustic effects, as if the structure was designed to combine light and sound in ways we're only beginning to understand. The Temple of Kukulkan at Chichen Itza demonstrates knowledge that seems impossible for its time period. Clap your hands at the base of the pyramid, and an echo returns sounding remarkably like the chirp of the sacred Quetzal bird. This isn't accident or coincidence. Acoustic analysis shows the pyramid's step angles and riser heights create precise frequency filtering. The structure transforms broadband handclap sounds into narrowband chirps, matching the bird's call. This requires understanding of sound wave reflection, frequency filtering, and architectural acoustics at a level we associate with modern concert hall design. What if ancient temples weren't built for worship, but were actually sophisticated machines that used sound to alter human consciousness? The implications unfold slowly. Prayer, chanting, ritual music practices we categorize as religious may have been sophisticated acoustic technology. Specific vowel sounds, sustained at precise pitches, activate architectural features designed to enhance and focus those vibrations. Monks chanting in cathedrals, Egyptian priests intoning in temple sanctuaries, shamans drumming in cave chambers, all potentially using human voice and percussion as tools to trigger responses built into the architecture itself. Modern neuroscience confirms what ancient builders apparently knew. Specific frequencies affect consciousness. Theta waves around 4 to 8 Hz induce deep meditation. Alpha waves at 8 to 12 Hz promote relaxed awareness. And that 110 Hz frequency that makes the hypogeum resonate. It sits right at the boundary where sound becomes feeling, where acoustic pressure creates physical sensation in tissues and bones. These structures weren't primitive religious buildings. They were precision instruments. The question expands outward from there. If ancient architects understood sound well enough to design buildings that manipulate consciousness through acoustic resonance, what else did they know about sound's properties? Did they use acoustic principles only in temples and sacred spaces, or did their understanding extend further? Could sound have been a tool not just for ceremony and consciousness, but for the practical work of construction itself? The stone blocks we've discussed, moved, and fitted with impossible precision, could acoustic technology have played a role in how they were shaped and positioned? The question leads us deeper into territory, where ancient myth and modern physics begin to overlap in unexpected ways. Acoustic levitation sounds like science fiction until you see the demonstrations. At NASA research facilities and university laboratories, objects float in mid-air, suspended by nothing but sound. Multiple speakers generate ultrasonic frequencies, creating interference patterns where sound waves converge and cancel. At these nodes, acoustic pressure becomes strong enough to counteract gravity. Small objects, water droplets, foam spheres, even dense materials hang motionless in invisible traps made of pure vibration. The physics is well established. Sound waves carry momentum. When waves reflect or interfere, they create pressure gradients. Make the pressure strong enough, and it can support physical mass against gravitational pull. Current technology limits this to small objects, but the principle scales. The question isn't whether sound can move matter. The question is whether ancient builders discovered this principle and developed it beyond our current applications. Historical accounts suggest they might have. In Tibet, multiple reports describe monks using drums, horns, and vocal chanting to move large stones up mountainsides. A Swedish doctor named Jarl claimed to witness this in 1939, describing an arc of musicians positioned at specific angles, producing coordinated sound that caused boulders to rise and travel hundreds of feet to a cliff ledge. His account was dismissed as fabrication or misunderstanding, but the details are oddly specific. 13 drums, 6 trumpets, precise positioning, coordinated rhythm. Ancient Egyptian texts reference priests using vowel sounds during construction. The accounts don't describe physical labor, but rather ritualized vocalizations performed at quarries and building sites. Medieval European sources mention words of power, capable of moving massive objects. The Catholic Church classified this as demonic magic and suppressed detailed descriptions, but fragments survived in grimoires and alchemical manuscripts. These could all be legends, myths, or misinterpretations. Or they could be cultural memories of actual technology described in the only terms available to people who witnessed effects without understanding mechanisms. Then, there's Coral Castle in Florida. Between 1923 and 1951, Edward Leedskalnin single-handedly quarried, carved, and erected over 1,000 tons of coral rock into an elaborate structure. The blocks weigh multiple tons each. Leedskalnin stood 5 feet tall and weighed 100 pounds. He worked alone, mostly at night. He claimed to know the secret of the pyramids, understanding how ancient Egyptians moved massive stones. He never revealed his method, but neighbors reported hearing him sing or chant while working. They described strange humming sounds coming from the construction site during night hours. When asked directly how he moved the stones, Leedskalnin spoke cryptically about magnetic currents, perpetual motion, and ancient wisdom. After his death, researchers found a flywheel and electromagnetic equipment in his workshop, but nothing explaining how a single person repositioned blocks that would challenge modern construction crews. The connection between sound and form becomes visible through cymatics. Place fine sand or liquid on a metal plate, vibrate the plate at specific frequencies, and the material organizes into geometric patterns. Low frequencies create simple forms. Higher frequencies generate increasingly complex geometries. Perfect circles, hexagons, mandalas, flower-like arrangements. Change the frequency and the pattern transforms instantly, matter responding to invisible vibration. These cymatic patterns look startlingly familiar. They match sacred geometry found in temples worldwide. The flower of life carved in Egyptian columns, mandala designs in Tibetan monasteries, Islamic geometric tile work, Celtic knots, Hindu yantras, all of them resembling the natural patterns that emerge when matter responds to specific vibrational frequencies. What we interpret as religious symbolism might be something else entirely. Ancient texts describe stones being moved with sound. Modern physics proves it's possible. What if the myths are actually forgotten instruction manuals? What if temple decorations aren't art but technical diagrams showing which frequencies produce which effects? The geometry wouldn't be symbolic but functional blueprints encoding acoustic information in visual form, preserving knowledge for those who understood how to read it. This raises uncomfortable possibilities about how much we've misunderstood. If ancient builders mastered acoustic principles well enough to use sound as a construction tool, they weren't primitive. They were sophisticated engineers working with physics we're only now beginning to explore seriously. And if they understood sound at this level, what other forces did they comprehend? Sound is one frequency of energy, but the spectrum extends far beyond what human ears detect. If ancients manipulated acoustic frequency, did they also work with electromagnetic frequency? Light, heat, electrical current, all manifestations of vibration at different scales. The knowledge wouldn't exist in isolation. Understanding one principle opens doors to others. The question becomes not whether they knew, but how far their knowledge extended. Ancient sacred sites share something beyond architectural ambition. They occupy specific locations, chosen with precision that suggests criteria we don't fully understand. Modern surveys using ground-penetrating radar and electromagnetic sensors reveal patterns. The great temples, pyramids, and stone circles weren't built randomly. They sit on geological anomalies, places where Earth's natural energy behaves differently. Underground water streams flow beneath many of these sites. Fault lines intersect at these points. Mineral deposits create zones where electromagnetic fields pulse in measurable patterns. Dowsers have known this for generations, finding these locations through methods science dismissed as superstition. Then researchers brought magnetometers and discovered the dowsers were detecting something real, electromagnetic variations strong enough to register on instruments. The hypogeum in Malta sits above underground water channels. Stonehenge occupies a location where multiple aquifers converge. The Great Pyramid rises above a subterranean river that still flows today. Machu Picchu perches at a point where geological faults create persistent electromagnetic anomalies. The pattern repeats globally. Sacred sites correlate with places where Earth's magnetic field shows unusual characteristics, nodes in a planetary energy grid that exists whether we acknowledge it or not. Some researchers have taken this observation further, mapping these locations and discovering something unexpected. Lines connect the sites. Not metaphorical connections, but geometric relationships spanning hundreds or thousands of miles. Stonehenge aligns with the Great Pyramid. Both connect to sites in the Americas through angular relationships that seem too precise for coincidence. This concept goes by various names: ley lines, dragon lines, Earth energy grids. Skeptics call it pareidolia, finding patterns where none exist. Plot enough points on a map and some will align by pure chance. But the alignments aren't random. They follow geometric principles. Equilateral triangles, hexagonal patterns, ratios matching sacred geometry found in the structures themselves. The probability of these relationships occurring naturally decreases as more connections emerge. Consider the mechanics. Sound travels through solid matter more efficiently than through air. Certain frequencies propagate through bedrock across vast distances with minimal loss. If ancient builders did use acoustic technology, location would matter enormously. Building at geological nodes where natural frequencies already concentrate would amplify their capabilities. Underground water creates resonance. Fault lines channel vibration. Mineral deposits conduct frequencies selectively based on their crystalline structure. Quartz appears consistently at these sites, not decoratively, but structurally. Granite rich in quartz content, quartz inclusions in foundation stones, quartz crystals deliberately placed in construction. This matters because quartz is piezoelectric. It generates electric charge under mechanical stress and vibrates when electrical current flows through it. A structure built with quartz-bearing stone, positioned over flowing water, located at a geomagnetic node, becomes something more than static architecture. It becomes a resonator, a transducer, converting one form of energy to another. They didn't just build monuments randomly. Every location was chosen for its acoustic and electromagnetic properties. It was all connected. The implications extend beyond individual structures. What if these sites formed a network, nodes in a system designed to function collectively? Each location resonates at specific frequencies determined by its geology and construction. If positioned correctly, they could communicate through the Earth itself, sending vibrational information through bedrock at frequencies we're only now learning to detect. Not communication in the sense of language, but perhaps transfer of energy, synchronization of resonance, or something else we lack frameworks to properly conceptualize. This reframes everything. We don't look at isolated monuments anymore. We see components of a planetary system, each piece placed deliberately within a larger design. The precision becomes even more impressive, not just building sophisticated structures, but positioning them in relationship to each other across continental distances. But this raises the practical question we keep circling back to: how? If sound was the theory, then architecture was the application. Understanding principles is one thing. Actually building these monuments is another. So we return to the stones themselves, to the physical reality of construction that somehow transformed knowledge into substance. In Cusco, Peru, a wall runs through the old city that shouldn't exist according to our understanding of ancient capabilities. The stones aren't uniform rectangles. They're irregular polygons, each one unique, fitted together with joints so tight that a razor blade won't slide between them. Some of these blocks weigh 200 tons. They interlock like three-dimensional puzzle pieces, each stone's surface matching perfectly with every adjacent surface, despite complex angles and curves that would challenge modern computer modeling. Stand close enough and you can run your hand along the seams. There's no gap, no mortar, just stone against stone in perfect contact across surfaces, measuring many feet. The blocks aren't just heavy, they're geometrically complex. Multiple faces, each face meeting neighbors at different angles. Each angle calculated to distribute weight and create structural integrity that has survived centuries of earthquakes in one of the most seismically active regions on Earth. The 12-angled stone has become famous precisely because it seems impossible. One stone with 12 distinct edges, each edge meeting a different neighboring block, all fitting with precision measured in fractions of millimeters. Modern engineers have studied this joint extensively. The computational complexity of designing such an interface staggers the imagination. You'd need to map each stone's position in three-dimensional space, calculate the angles where surfaces meet, account for weight distribution and seismic stress, then manufacture each piece to exact specifications. With computer-aided design software and CNC cutting machines, this remains challenging. The claim is that it was accomplished with stone hammers and bronze chisels. Modern masons have attempted replication. They fail consistently, not from lack of skill or effort, but because the task requires precision that hand tools don't provide. You can approximate these joints with significant time investment. You cannot achieve the accuracy present in Cusco's walls without measurement systems and manufacturing techniques that supposedly didn't exist when these walls were built. The standard explanation involves time and patience. Given enough generations of workers, enough trial and error, the stones could be shaped and reshaped until they fit. But this explanation encounters problems when examined closely. Trial and error works for simple joints between two stones. When you're fitting irregular polygons where each stone contacts 5 or 6 or 12 neighbors, all simultaneously requiring perfect contact, the complexity increases exponentially. Make one adjustment and you've potentially compromised multiple other interfaces. Templates could theoretically solve this problem. Create precise models showing how stones should fit, then manufacture to match the templates. But this pushes the question back one level. How were the templates created with such precision? And why do we find no evidence of these templates? No discussion of them in historical records, no preserved examples. At Pumapunku in Bolivia, the precision reaches another level entirely. The H-blocks present a manufacturing mystery that resists all conventional explanations. These aren't simple rectangular shapes. They're complex forms with channels, notches, and protrusions that align across multiple stones with tolerances under 1 millimeter. The surfaces are flat to a degree that modern machinists recognize as machine-quality work. The angles are exact. The symmetry is perfect. The joints are so perfect that even modern lasers struggle to match them. And these stones weigh as much as loaded 747 seconds. How? If you accept that these were carved from solid andesite using primitive tools, you must explain how workers achieved precision that challenges current technology. If you reject primitive tools and propose more advanced techniques, you must explain where those techniques came from and why no clear evidence of them remains beyond the stonework itself. A controversial alternative suggests itself. What if these stones weren't carved at all? What if they were cast? Geopolymer theory proposes that ancient builders possessed chemical knowledge, allowing them to create a form of concrete from crushed stone and binding agents. Mix the components, pour into molds, allow to cure. The result looks identical to natural stone, because it is stone, just stone, that was temporarily liquefied and reformed rather than cut from bedrock. Evidence exists to support this theory. Many megalithic blocks show no tool marks whatsoever, as if they emerged fully formed. Some contain organic materials, hair, textiles, insect parts trapped within the stone matrix in ways that shouldn't occur in natural geological formation. Chemical analysis of certain blocks reveals mineral compositions slightly different from quarries they supposedly came from, with trace elements suggesting artificial binding agents. The theory remains controversial, dismissed by mainstream archaeology, but defended by materials scientists who see chemical signatures they recognize from synthetic processes. If true, it would explain the precision. Molds can be exact. Poured material takes the shape of its container perfectly. Complex multi-stone joints become possible if you cast stones in sequence, each new pour forming against the previous stone's surface. But even if we accept this explanation, even if we solve the mystery of how these joints achieved such precision, we face another question equally challenging. These stones exist at their current locations. Whether carved or cast, they're massive. Moving them from quarries or positioning them within structures required capabilities that seem equally impossible. Perfect joints tell us about manufacturing sophistication, but transportation and placement reveal something else: mastery over forces that should have been beyond ancient technology's reach. In Baalbek, Lebanon, 3 stones form the foundation of the Temple of Jupiter. They're called the trilithon. Each weighs approximately 800 tons. Nearby, still in the quarry, lies the stone of the pregnant woman. It weighs close to 1,000 tons, 2 million pounds of precisely cut limestone. Modern heavy-lift cranes max out around 20,000 tons, but they require stable ground, reinforced foundations, and careful load distribution. Moving a 1,000-ton stone would demand specialized transport vehicles that don't exist in any construction fleet today. Yet somehow, over 2,000 years ago, this stone was quarried. It was cut free from bedrock, using techniques that left surfaces smooth and edges straight. The intention was clearly to move it, to incorporate it into the temple structure where its companion stones already rested, lifted 20 feet above ground level and fitted into place with precision. The standard explanation involves manpower. Estimates suggest tens of thousands of workers pulling ropes attached to the stone, which rests on wooden rollers or sledges. The mathematics behind this explanation reveal its problems quickly. 1,000 tons equals the weight of roughly 700 automobiles. Distribute that load across rollers, and you need wood that won't splinter under concentrated pressure. Rope strong enough to pull such weight without breaking must be exceptionally thick hemp or flax rope, as thick as a human torso. No archaeological evidence of such rope exists because organic materials disintegrate over millennia. Even granting rope and rollers that could theoretically work, the geometry creates insurmountable problems. To pull effectively, workers need space to stand and leverage to apply force. Calculate the number of people required, and you quickly exceed the physical space available around the stone. They'd be pulling at sharp angles where most force is wasted, and this assumes flat terrain. The route from quarry to temple isn't flat. It includes slopes, turns, and uneven ground where 1,000-ton stone on rollers would become uncontrollable. Easter Island presents similar mysteries at a smaller, but still challenging scale. The Moai statues weigh 10 to 20 tons. Recent experiments demonstrated that teams can walk smaller statues upright by rocking them side to side with ropes, shuffling them forward incrementally. This works for statues under 15 tons on relatively flat terrain. The largest Moai weighs 82 tons. It was moved anyway. No one has successfully demonstrated how. The island's population at its peak numbered perhaps 15,000 people. They had no wheels, no draft animals, no metal tools. They carved and transported nearly 900 statues across terrain that ranges from gradual slopes to steep volcanic rock. Some statues travelled more than 10 miles from quarry to final location. Doing this even once would challenge modern logistics. They did it repeatedly for generations. They moved 1,000-ton stones uphill without wheels, without steel, without cranes. Every explanation we have requires rewriting what we know about ancient capabilities. Alternative theories fill the space where conventional explanations fail. Some researchers return to acoustic levitation, suggesting that if sound can suspend small objects in laboratory conditions, perhaps ancient technology developed this principle to scales we haven't achieved. The evidence remains indirect. Legends of stones moved by sound, accounts of chanting and drumming during construction, but no preserved mechanism or clear documentation. Others propose lost understanding of gravitational manipulation, knowledge that stones aren't inherently heavy, but only appear so due to Earth's gravitational field, and that this field could be locally modified through means we don't comprehend. This ventures into speculative territory where physics as we understand it stops providing frameworks. The geopolymer theory offers a more prosaic explanation. If stones weren't moved but created on site, the transportation problem disappears. You transport raw materials, crushed stone, binding agents, water in manageable quantities, then cast massive blocks in place. This doesn't require rewriting physics, only acknowledging lost chemical knowledge. Egyptian quarries add another dimension to the mystery. Granite blocks show saw marks, straight cuts penetrating deep into some of Earth's hardest stone. Copper is softer than granite. Sawing granite with copper shouldn't be possible, yet the marks exist. Either the copper was alloyed in ways that increased hardness beyond what we've replicated, or the sawing process involved abrasives, probably sand or corundum, creating a cutting slurry that did the actual work, while copper provided pressure. But even this explanation encounters problems when you examine cut rates. Experimental archaeology using copper saws and sand abrasives achieves cut depths of a few millimeters per hour. Some Egyptian blocks show cuts several feet deep. The time investment becomes implausible unless they possess techniques significantly more efficient than our reconstructions suggest. Each answer generates new questions. Solve transportation, and you still face placement. These stones didn't just need to move horizontally, they needed to rise vertically, lifted to precise heights, and positioned with accuracy that required understanding their final resting place before moving them at all. The engineering extends beyond simple force application into realms of planning and spatial reasoning that imply sophisticated knowledge we haven't fully credited to these ancient builders. The Great Pyramid rises 480 feet into the Egyptian sky. At its summit, limestone blocks weighing 2.5 tons each sit precisely positioned. Getting them there required lifting each block higher than a modern 40-story building, then placing it with accuracy measured in fractions of inches. This happened over 2 million times during the pyramid's construction. The conventional explanation involves ramps. Build an inclined plane, drag the stones upward, gradually raise the ramp as the pyramid grows. The theory sounds reasonable until you calculate the dimensions such a ramp would require. To maintain a slope gentle enough for dragging multi-ton loads, the ramp would need to extend over a mile from the pyramid's base. The volume of material in such a ramp would exceed the volume of the pyramid itself. You'd essentially build 2 pyramids, one temporary ramp and one permanent structure, then dismantle the ramp completely, leaving no archaeological trace. Internal ramp theories attempt to solve this problem by proposing that ramps spiraled up through the pyramid's interior or along its outer faces. But these designs encounter different problems. Tight corners become impossible with long, heavy loads. The confined spaces don't allow room for the crews needed to pull stones. And again, archaeological evidence for these internal ramps remains conspicuously absent. At the summit, 480 feet high, each stone placed perfectly, no crane, no helicopter, no explanation that adds up. What aren't we seeing? Ollantaytambo in Peru presents an even more theatrical challenge. Massive granite blocks, some weighing 50 tons, form walls on a steep mountainside high above the valley floor. The stone is rose-colored granite with unique mineral composition. Its source quarry sits across the valley, on a different mountain, separated by the Urubamba River. The blocks travel down one mountain, across water somehow, then up the opposing slope, before being lifted dozens of feet into walls that still stand with precision joinery. Modern engineers examining this site struggle to propose credible methods. You need to descend a steep slope with massive loads, cross a river without bridges capable of bearing such weight, then ascend an equally challenging grade on the opposite side. Once there, the blocks must rise vertically and slot into positions predetermined with extraordinary accuracy. Contemporary construction projects, requiring similar work, deploy helicopters, mobile cranes, rated for enormous loads, or cable systems anchored to stable points. None of these technologies supposedly existed in pre-Columbian Peru. At Tiahuanaco and Pumapunku in Bolivia, the challenge intensifies through altitude. These sites sit at 12,800 feet above sea level. The air contains roughly 40% less oxygen than at sea level. Physical labor becomes significantly more difficult. Yet blocks exceeding 100 tons were lifted and positioned with astronomical precision. Literally astronomical, as the alignments track celestial events with accuracy requiring sophisticated surveying. Alternative theories attempt to bridge the gap between ancient capabilities and demonstrable achievements. Counterweight systems could theoretically lift enormous loads using massive stone weights on the opposite end of lever arms. Pulley systems with multiple blocks could provide mechanical advantage, reducing the force required. Advanced crane mechanisms, using principles we associate with later periods, might have existed in forms that left no surviving examples. Ancient art provides intriguing hints. Egyptian reliefs show objects that some researchers interpret as mechanical devices rather than purely symbolic representations. Mesopotamian cylinder seals depict figures operating what appear to be complex apparatus. These interpretations remain controversial, but the images exist and resist simple explanation. Ancient texts add another layer. Sanskrit epics describe vimanas, flying vehicles, or celestial chariots with detailed operational instructions. Egyptian temple inscriptions reference boats of the gods that traveled through air and water equally. Medieval European texts mention mechanical marvels built by ancient artificers, knowledge supposedly lost when Rome fell. These accounts get dismissed as mythology, metaphor, or fantasy. But what if some percentage describes actual devices in the only language available to cultures encountering technology they couldn't fully comprehend? The narration doesn't insist these texts describe helicopters or cranes as we'd recognize them, but it asks whether dismissing them entirely as pure fiction might be premature. Perhaps they preserve distorted memories of lifting technologies more sophisticated than wooden ramps and hemp rope. The gap persists between what ancient builders supposedly possessed and what they demonstrably accomplished. Stones weighing hundreds of tons positioned at heights and locations that challenge modern capability. Every conventional explanation requires assumptions that strain credibility when examined closely. Every alternative explanation ventures into territory where evidence becomes circumstantial and interpretation subjective. Yet the structures stand. They were built. The stones were lifted. However, it was accomplished. It was accomplished. The mystery isn't whether they did it, the mystery is how. And that mystery connects to something perhaps even more profound, the knowledge encoded within these structures themselves. Stand at the base of the Great Pyramid of Giza and look up at the weathered limestone blocks rising into the Egyptian sky. According to our history books, the builders who constructed this monument in 2560 BCE were primitive by our standards. They had no knowledge of advanced mathematics, no understanding of pi, no concept of the golden ratio. They were simply skilled laborers following the pharaoh's orders, stacking stones until they reached the heavens. But the stones tell a different story. Measure the Great Pyramid's perimeter and divide it by twice its height. The answer is pi 3.14159, accurate to several decimal places. This ratio appears in the fundamental design, encoded into proportions that can't be accidental. The Greeks wouldn't formally describe pi until around 250 BCE, more than 2,000 years after this pyramid rose from the desert sand. The slope angle of the pyramid faces relates directly to the golden ratio phi, another mathematical constant supposedly unknown to ancient Egypt. More unsettling still, the pyramid's dimensions mirror the proportions of Earth's northern hemisphere at a scale of 1:43,200. To encode this relationship, the builders would need to know the exact size and shape of the planet itself. The question hangs in the air like desert heat. How did they know? How did Bronze Age workers encode mathematical relationships that wouldn't be discovered for millennia? The official answer involves coincidence, trial and error, aesthetic preferences that happen to align with advanced mathematics. But when coincidence stacks upon coincidence upon coincidence, the explanation starts to feel less like scholarship and more like avoidance. Travel north to the wind-swept plains of England. Stonehenge rises from the grass. Massive sarsen stones arranged in patterns, we're told, served religious purposes, marking the summer solstice for primitive ceremonies. But measure the positions carefully. The stones don't just track the sun. They encode the metonic cycle, the 19-year pattern that harmonizes solar and lunar calendars. This cycle wouldn't be formally described until the Greek astronomer Meton documented it in 432 BCE. Yet Stonehenge demonstrates this knowledge in stone, built around 3000 BCE, predating Meton by more than 2,500 years. The arrangement predicts eclipses, tracks lunar movements with precision that requires not just observation but mathematical calculation. Across the ocean, deep in the Yucatan jungle, the temple of Kukulkan rises in stepped pyramids toward the sky. Count the stairs. 91 steps on each of the four sides, plus the temple platform at the top. The total is 365 the days in a solar year. The architects, we're told, were simply creating symbolic architecture, but stand at the base and clap your hands. The pyramid reflects the sound back as a chirping echo that perfectly matches the call of the sacred Quetzal bird. This acoustic property requires sophisticated understanding of sound wave reflection, frequency, and architectural design. It's not symbolic, it's engineered. The Mayans tracked Venus with precision that matches modern astronomical measurements. To achieve this accuracy, they needed centuries of careful observation and complex mathematical calculations involving cycles, fractions, and long-term pattern recognition. Their calendars interlocked multiple cycles, solar, lunar, and planetary in mathematical harmonies that required advanced computation. These weren't primitive priests guessing at the sky. These were mathematicians. In Peru, massive geometric figures stretch across the Nazca Desert, visible only from the air. The lines run perfectly straight for miles across uneven terrain. Modern surveyors study these figures with professional amazement. Creating such precision over vast distances requires standardized measurement systems, sighting techniques, and geometric principles. The Nazca lines date to somewhere between 500 BCE and 500 CE, yet they demonstrate engineering capabilities we associate with much later periods. The straight lines deviate by less than 2 meters per kilometer accuracy that challenges even modern methods without sophisticated tools. We're taught that mathematical knowledge progressed linearly, that ancient peoples discovered these constants gradually through centuries of Greek and Islamic scholarship. But the stones, the pyramids, the desert lines, they all whisper something different. They suggest that someone, somewhere, understood these mathematical relationships long before history says such knowledge existed. The numbers are there, carved in stone and built into angles, waiting for anyone willing to measure. The question isn't whether the mathematics exist. The question is who taught them these equations, and why don't our history books mention it? If they understood advanced mathematics, they could map the heavens. And what they knew about the cosmos might be the most suppressed secret of all. Look at the 3 pyramids of Giza from above and notice their arrangement. They don't sit in a perfect line. They're offset, with the smallest pyramid positioned slightly east of the alignment formed by the other 2. For decades, Egyptologists described this as an architectural quirk, perhaps a limitation of the terrain or a design preference lost to time. But in the night sky above Egypt, 3 stars in Orion's belt shine in exactly this pattern. The same offset, the same proportions. The pyramids mirror the stars with precision that goes beyond coincidence. The correlation deepens when you look at the larger context. The Nile River flows beside the pyramid complex, its position relative to the monuments matching the Milky Way's position relative to Orion in the night sky. The ancient Egyptians called the Milky Way the Nile in the sky. They weren't being poetic. They were describing a map. But here's where the accepted timeline begins to fracture. When you account for precession, the slow wobble of Earth's axis that shifts the position of stars over millennia, the alignment between Orion's belt and the pyramids reaches perfection around 10,500 BCE. That's 8,000 years before Egypt supposedly built these monuments. Precession is a 26,000-year cycle during which Earth's rotational axis traces a slow circle against the background of stars. It's an astronomical phenomenon that requires centuries of careful observation to detect and complex mathematics to calculate. Ancient civilizations shouldn't have known about it. The Greek astronomer Hipparchus is credited with discovering precession around 127 BCE. Yet references to this cycle appear in myths and monuments worldwide, encoded in symbolism that predates Hipparchus by thousands of years. Travel east to the jungles of Cambodia. Angkor Wat rises from the forest, a temple complex covering more than 400 acres, its towers reaching toward the sky. Map the positions of its main structures and overlay them on star charts. The temples mirror the constellation Draco, not as it appears in our current sky, but as it appeared in 10,500 BCE, the same date, the same astronomical reference point, different continent, different culture, same cosmic timestamp encoded in stone. This date keeps appearing. Researchers examining ancient sites across the globe find this specific astronomical alignment repeated in monuments separated by oceans and millennia of supposed isolation. Either this represents the most remarkable coincidence in archaeological history, or something significant happened around 10,500 BCE that multiple civilizations wanted to commemorate, something they encoded in permanent structures designed to survive catastrophe. At Chichen Itza, windows in the observatory frame Venus at its extreme northern and southern positions. At Stonehenge, stones align with summer solstice sunrise with such precision that the sun's first rays illuminate specific markers on that single morning each year. These are the famous alignments, the ones mentioned in textbooks. But archaeoastronomers have discovered hundreds more subtle correlations tracking planetary cycles, stellar positions, and astronomical events with accuracy that requires not just observation but prediction. They weren't simply watching the sky. They were calculating it. Some of this knowledge presents problems that don't resolve easily. Ancient texts describe celestial bodies invisible to the naked eye. The Dogon tribe of Mali possessed detailed knowledge of Sirius B, a white dwarf star orbiting Sirius that remained invisible until telescopes confirmed its existence in 1970. They described its 50-year orbital period and its incredible density facts that shouldn't be accessible without modern astronomical equipment. When anthropologists asked how the Dogon knew these things, the elders spoke of visitors from the sky who taught them about the stars. Ancient Sumerian texts describe planets by color and size with accuracy matching modern observation. Sanskrit writings contain references to moons of Jupiter and rings of Saturn, features invisible without optical magnification. The official explanation suggests lucky guesses. Mythological invention later assigned astronomical meaning. But the numbers are too precise, the descriptions too accurate. They mapped stars they couldn't see with naked eyes. They tracked cycles lasting 26,000 years. They encoded this knowledge in monuments designed to last through catastrophe. The stones weren't meant for their present. They were meant for their future, for whoever would survive to read them. Why encode information in permanent monuments? What were they preparing for? And what do ancient texts really say about cataclysms that destroyed previous worlds? The golden ratio appears in the spiral of a nautilus shell, the arrangement of seeds in a sunflower, the proportions of the human body. This number 1.618, represented by the Greek letter phi, creates patterns that humans find instinctively beautiful. Nature uses it everywhere. So do ancient architects. The Parthenon in Athens, built in 447 BCE, embodies golden ratio proportions in its facade, its columns, its interior spaces. Notre Dame Cathedral, constructed centuries later in medieval France, incorporates the same ratios in its towers, its rose windows, its vaulted ceilings. The Great Pyramid encodes it in relationships between its dimensions. Different continents, different eras, different religions, same mathematical principle. This isn't isolated knowledge. It's a language, a geometric vocabulary appearing across cultures with no accepted contact between them. The Fibonacci sequence, where each number equals the sum of the two preceding numbers, generates spirals matching those in galaxies, hurricanes, and ancient temple designs from Cambodia to Mexico. Pentagonal symmetry, the five-pointed star, appears in starfish and flowers, but also in Sumerian seals, Christian iconography, and Islamic architecture. Either humans everywhere independently discovered these relationships, or someone taught a universal design language that survived through millennia of civilizational collapse. Look at the Vesica Piscis, two circles of equal size overlapping so each circle's center touches the other's edge. This simple geometric form appears carved in stone at the Temple of Osiris in Egypt, dated to thousands of years BCE. It decorates Gothic cathedral windows throughout medieval Europe. It forms the basis of Buddhist mandalas across Asia. The same shape, encoded with sacred significance, appearing in religious architecture separated by vast distances and enormous spans of time. Modern geometry reveals the Vesica Piscis contains within it the square root of 3, and generates proportions found throughout living systems. Did ancient builders understand this mathematically, or were they copying a template whose deeper meaning they'd forgotten? In the Egyptian temple at Abydos, on a massive granite column, archaeologists found the flower of life carved into the stone. This pattern consists of multiple overlapping circles arranged in a hexagonal lattice, creating a mesmerizing geometric form. The same pattern appears on Phoenician artifacts, in Buddhist temples across Asia, in ancient manuscripts from cultures with no historical connection. Esoteric traditions claim this pattern contains the fundamental forms of space and time, that it represents the structure of reality itself at quantum levels. Dismiss this as mysticism if you want, but modern physics reveals that atomic structures, crystal formations, and energy field patterns follow geometric rules that mirror these ancient designs with unsettling accuracy. The Platonic solids, 5 three-dimensional shapes where all faces are identical, regular polygons, appear in ancient Greek philosophy. But they also show up in Neolithic carved stone balls from Scotland, dated 1,000 years before Plato. These shapes aren't arbitrary. They represent the only possible ways to construct regular polyhedra. Modern chemistry reveals they describe atomic structures and molecular bonds. Did Stone Age craftsmen carve these specific geometric forms by accident? Or did they possess knowledge about matter's fundamental architecture? Researchers measuring megalithic sites across Europe discovered something peculiar. Stone circles in England, France and Scotland appear to use a standardized unit of measurement, the megalithic yard, approximately 2.72 feet. These sites date to between 3000 and 2000 BCE. Long before accepted histories say these cultures had contact. How did builders separated by hundreds of miles adopt identical measurement standards? The answer suggests either far more sophisticated ancient trade networks than we acknowledge, or remnants of an earlier civilization whose technical knowledge spread before it vanished. Walk through any great cathedral or ancient temple, and you're walking through mathematics made tangible. The proportions aren't decorative choices, they're encoded relationships. Root 2 rectangles, where the long side equals the short side multiplied by the square root of 2, appear in Egyptian tomb designs and Japanese temple layouts. Pi shows up in the ratios between different architectural elements. Phi determines the spacing of columns and the height of doorways. These buildings are three-dimensional textbooks, teaching geometric principles through physical form. The same geometric patterns, the same mathematical ratios, on every continent separated by oceans and supposedly by thousands of years. They all learned from someone, or something. The consistency can't be coincidental. It suggests a source, a teaching that predates recorded history, encoded in the only language that survives the collapse of civilizations, pure mathematics frozen in stone. Mathematics and astronomy are theoretical knowledge, but building requires energy. What power did they harness? In 1936, workers excavating near Baghdad unearthed a small clay jar, unremarkable except for what it contained. Inside, the terracotta vessel sat a copper cylinder, and within that cylinder, an iron rod. The objects dated to approximately 250 BCE, part of the Parthian civilization that ruled Mesopotamia 2,000 years ago. Archaeologists catalogued the find and stored it away. They called it a storage jar, perhaps for scrolls or sacred texts. But someone eventually noticed something peculiar. The copper showed signs of corrosion from acidic substances. The iron rod was suspended in the center, never touching the copper walls. The jar's opening was sealed with asphalt. Fill this vessel with vinegar or wine, both readily available to ancient Mesopotamians, and it generates electricity. Approximately 1 volt, measurable, reproducible, functional. This shouldn't exist. The official history of electricity begins in the 18th century, with experiments involving amber and static charge, progressing through Volta's pile in 1800, the first true battery. Yet here sits an electrochemical cell, buried in Mesopotamian soil for over 2 millennia, predating Volta by 2,000 years. The archaeological establishment dismisses it. They suggest alternative purposes, insist the electrical generation is coincidental, a happy accident of construction that mimics battery design without intentional function. But replicas work perfectly. Engineers have built duplicates following the ancient design, and every single one generates current when filled with acidic liquid. The function is undeniable. The question hangs in the museum air. If ancient Mesopotamians possessed batteries, what did they power? A single volt seems too small for practical use by modern standards, but electroplating requires only small, sustained current. Evidence of sophisticated gilding techniques appears throughout the ancient world. Gold layers so thin and uniform, they suggest electrical deposition rather than mechanical application of gold leaf. Connect enough Baghdad batteries in series, and you generate sufficient voltage for plating. Some ancient gold artifacts display characteristics consistent with electroplating, though this interpretation remains controversial, contested by archaeologists unwilling to accept such advanced techniques in antiquity. Travel to Dendera Temple in Egypt. On the walls of a crypt beneath the main structure, carved reliefs show strange, elongated objects that look disturbingly like light bulbs. Long oval shapes, supported on pillars, with wavy lines inside suggesting filaments. Braided cables emerge from these objects, running to box-like structures that resemble modern battery cases. Figures hold these bulbs, manipulating them in ways that suggest technical operation rather than ceremonial display. Mainstream Egyptology interprets these images as symbolic lotus flowers, religious iconography representing creation myths. But the details don't match botanical forms, they match electrical schematics. Experimental archaeologists built working models based on these dendera reliefs. Using only materials available to ancient Egyptians, copper, salt water, electrodes, they created sustained electrical light. The devices worked. This raises uncomfortable questions about how Egyptians illuminated the depths of their tombs and tunnels. Miles of underground passages contain intricate paintings covering walls and ceilings. These artworks required sustained, steady light for artists to work. Yet soot marks from torches are notably absent in many of these spaces. Torches produce carbon deposits. Oil lamps leave residue. But many Egyptian underground chambers show neither, despite elaborate decorations that required hours of illuminated work to complete. The evidence extends beyond batteries and theoretical lights. The Lycurgus cup, a Roman glass vessel from the 4th century CE, changes color depending on how light strikes it. Illuminate it from outside, and it appears jade green. Shine light from within, and it glows ruby red. This dichroic property results from gold and silver nanoparticles suspended in the glass matrix, at precise concentrations particles between 50 and 100 nanometers in diameter. Modern material science didn't achieve this until 1990. The technology to create such nanoparticles, to suspend them uniformly in molten glass, to control their size with nanometer precision, none of this should exist in ancient Rome. Yet the cup is unquestionably genuine, its age verified through multiple analytical methods. Museums display these artifacts behind glass. Labels describe them in conventional terms, explaining away their anomalous properties with theories that strain credibility. A jar that functions as a battery is called a scroll container. Reliefs depicting electrical equipment are interpreted as flowers. A cup demonstrating nanotechnology is dismissed as fortunate accident. But the objects remain, physical evidence that doesn't conform to accepted timelines of technological development. They called it a storage jar. But when you fill it with vinegar and connect wires, it generates electricity. Why would ancient Mesopotamians build batteries? If they had electrical power, even small amounts, what did they use it for? And could there have been larger-scale power generation we've completely missed? Stand inside the king's chamber of the Great Pyramid and listen to the silence. According to every textbook, you're inside a tomb, a pharaoh's final resting place, built to house his mummified body for eternity. But no mummy was ever found here. No hieroglyphics decorate these walls, no funerary texts, no paintings of the afterlife. None of the elaborate decoration that defines every other Egyptian tomb. Just bare granite walls, precisely cut and fitted with tolerances measured in fractions of millimeters. This doesn't feel like a tomb. It feels like a machine. Christopher Dunn, a master craftsman and engineer, spent decades analyzing the Great Pyramid's internal structure. His conclusion challenges everything we're taught. The pyramid wasn't a tomb. It was a power plant, a massive power generation facility built by people who understood principles of energy conversion we consider modern discoveries. The hypothesis sounds absurd until you examine the technical details. The granite blocks forming the king's chamber contain high concentrations of quartz crystal. Quartz is piezoelectric. When you compress it, it generates electrical current. When you subject it to vibration, it produces voltage. The chamber itself sits positioned precisely to create acoustic resonance. Sound waves entering the shafts and chambers would amplify at specific frequencies, creating powerful standing waves that vibrate the quartz-bearing granite. This mechanical vibration generates electrical potential. The chamber's dimensions match calculations for optimal resonance frequency. Below the pyramid runs an underground water channel, mapped through seismic surveys. Water flowing through chambers beneath the structure could create pressure oscillations. These pressure waves propagating upward would stress the granite, causing the quartz crystals to generate piezoelectric current. The subterranean chamber shows erosion patterns inconsistent with natural weathering. The walls display damage, suggesting exposure to powerful chemicals. Perhaps the remains of chemical reactions that once took place there. part of an electrochemical system, generating hydrogen or processing materials for energy production. The granite coffer in the king's chamber, traditionally called a sarcophagus, has dimensions that don't match human proportions. It's too large, oddly shaped, and its corners are cut with precision, requiring advanced machining. Strike it, and it rings like a bell, resonating at specific frequencies. Its measurements correspond to harmonic relationships used in acoustic engineering. If this was a tomb, why build a sarcophagus that functions as a precision resonator? Salt deposits coat certain internal passages, concentrated in areas where electrochemical reactions would occur if the structure processed solutions. Copper fixtures remain embedded in shafts. Copper, an excellent conductor, positioned in ways that make no sense for ventilation or astronomical alignment, but would function perfectly as electrical contacts. These details accumulate. Individually, each might be explained away. Collectively, they describe something far more sophisticated than a burial monument. Beyond Egypt, the megalithic temples of Malta contain underground chambers with acoustic properties that amplify specific low frequencies. Researchers measuring electromagnetic fields at these sites have detected anomalies, fluctuations in background radiation that spike during equinoxes and solstices. The structures sit positioned at geological formations where natural telluric currents flow through rock currents that concentrate electrical potential differences between layers of conductive and insulating stone. Nikola Tesla believed Earth itself could function as a conductor for wireless power transmission. His Wardenclyffe Tower, built in 1901, attempted to tap into natural electrical currents flowing through the planet's crust. These telluric currents exist everywhere, but they concentrate at specific geological nodes, places where conductive rock formations meet aquifers, where natural resonance frequencies amplify. Tesla theorized that ancient builders understood this principle, deliberately constructing monuments at power concentration points in a planetary energy grid. The idea sounds like fringe science until you notice the pattern. Megalithic sites worldwide sit positioned at geological formations with unusual electromagnetic properties. They're built with stones containing high quartz content. They incorporate water channels, acoustic chambers, and geometric proportions that maximize resonance. Modern electrical engineers examining these structures recognize design elements: insulation, conduction paths, resonance chambers, and frequency-specific architecture. What if the Great Pyramid wasn't a tomb, but a machine? A power plant that once generated massive amounts of energy, built by people who understood principles we're only rediscovering. The chamber contains no bodies, because it never housed the dead. The precision wasn't for aesthetics, it was functional requirement. And the silence you hear standing inside isn't the quiet of a tomb. It's the absence of the hum that once filled this space when the machine was running. Electricity is one form of energy. But what about the forces that hold matter together? What about atomic understanding? Stand inside the king's chamber of the Great Pyramid and listen to the silence. According to every textbook, you're inside a tomb. A pharaoh's final resting place, built to house his mummified body for eternity. But no mummy was ever found here. No hieroglyphics decorate these walls. No funerary texts. No paintings of the afterlife. None of the elaborate decoration that defines every other Egyptian tomb. Just bare granite walls, precisely cut and fitted with tolerances measured in fractions of millimeters. This doesn't feel like a tomb. It feels like a machine. Christopher Dunn, a master craftsman and engineer, spent decades analyzing the pyramid's internal structure. His conclusion challenges everything we're taught. The pyramid wasn't a tomb. It was a power plant. A massive facility built by people who understood energy conversion principles we consider modern discoveries. The hypothesis sounds absurd until you examine the technical details. The granite blocks forming the king's chamber contain high concentrations of quartz crystal. Quartz is piezoelectric. Compress it, and it generates electrical current. Subject it to vibration, and it produces voltage. The chamber sits positioned precisely to create acoustic resonance. Sound waves entering the shafts would amplify at specific frequencies, creating standing waves that vibrate the quartz-bearing granite. This mechanical vibration generates electrical potential. The chamber's dimensions match calculations for optimal resonance frequency. Below the pyramid runs an underground water channel, mapped through seismic surveys. Water flowing beneath the structure could create pressure oscillations that stress the granite, causing quartz crystals to generate piezoelectric current. The subterranean chamber shows erosion patterns inconsistent with natural weathering damage, suggesting exposure to powerful chemicals, perhaps remains of reactions that once generated hydrogen or processed materials for energy production. The granite coffer in the king's chamber, traditionally called a sarcophagus, has dimensions that don't match human proportions. Strike it, and it rings like a bell, resonating at specific frequencies. Its measurements correspond to harmonic relationships used in acoustic engineering. Why build a sarcophagus that functions as a precision resonator? Salt deposits coat certain internal passages, concentrated where electrochemical reactions would occur if the structure processed solutions. Copper fixtures remain embedded in shafts. Copper, an excellent conductor, positioned in ways that make no sense for ventilation, but would function perfectly as electrical contacts. These details accumulate. Individually, each might be explained away. Collectively, they describe something far more sophisticated than a burial monument. Beyond Egypt, the megalithic temples of Malta contain underground chambers with acoustic properties amplifying specific low frequencies. Researchers measuring electromagnetic fields at these sites detect anomalies, fluctuations spiking during equinoxes and solstices. The structures sit at geological formations where natural telluric currents flow through rock, concentrating electrical potential between layers of conductive and insulating stone. Nikola Tesla believed Earth itself could function as a conductor for wireless power transmission. His Wardenclyffe Tower attempted to tap natural electrical currents flowing through the planet's crust. These telluric currents concentrate at specific geological nodes, places where conductive rock meets aquifers, where resonance frequencies amplify. Tesla theorized ancient builders understood this principle, constructing monuments at power concentration points in a planetary energy grid. The pattern appears worldwide. Megalithic sites sit at geological formations with unusual electromagnetic properties. They're built with stones containing high quartz content. They incorporate water channels, acoustic chambers, and geometric proportions maximizing resonance. Modern electrical engineers examining these structures recognize design elements: insulation, conduction paths, resonance chambers, frequency-specific architecture. What if the Great Pyramid wasn't a tomb, but a machine? A power plant that once generated massive amounts of energy, built by people who understood principles we're only rediscovering. The chamber contains no bodies because it never housed the dead. The precision wasn't for aesthetics, it was functional requirement. And the silence you hear standing inside isn't the quiet of a tomb. It's the absence of the hum that once filled this space when the machine was running. Electricity is one form of energy, but what about the forces that hold matter together? What about atomic understanding? In the 1,990 seconds, British archaeologist David Davenport examined skeletal remains from Mohenjo-Daro, an ancient city in modern Pakistan dating to approximately 2,500 BCE. The bones told a disturbing story. Some showed patterns of sudden, intense heat exposure. Scattered across the site, pottery had vitrified, melted into glass. Stone surfaces showed evidence of temperatures exceeding 2,000 degrees Celsius. Radiation levels at certain locations remained elevated, measurably above background levels. Mainstream archaeology attributes this damage to ancient fires, perhaps from warfare or accident. But achieving such temperatures with wood or oil fires presents significant challenges. And fires don't typically leave radioactive signatures in soil millennia later. The ancient Indian epic Mahabharata, composed thousands of years ago, describes weapons called Brahmastra. The text provides details that make modern readers uncomfortable. A single projectile charged with all the power of the universe. An incandescent column of smoke and flame bright as 10,000 suns. A gigantic messenger of death reducing entire armies to ash. Corpses so burned as to be unrecognizable, hair and nails falling out. These aren't vague mythological descriptions. They match the observable effects of nuclear weapons with unsettling precision: mushroom clouds, thermal radiation, blast waves, and symptoms consistent with acute radiation sickness. We could dismiss these texts as imaginative fiction, mythology inflated through generations of oral tradition. But then we encounter the physical evidence: layers of vitrified stone, elevated radiation readings, heat damage patterns suggesting explosive rather than gradual combustion. The archaeology and the ancient texts describe the same thing from different angles. In 1972, French scientists examining uranium deposits at Oklo in Gabon, Africa, discovered something impossible. Natural nuclear fission reactions had occurred there 2 billion years ago. Specific geological conditions concentrated uranium isotopes to critical mass, initiating sustained chain reactions that operated for hundreds of thousands of years. This proves natural nuclear reactors can exist without modern technology or human intervention. The necessary conditions are rare but achievable through natural processes, which raises a question. If nature can accidentally create nuclear reactions, could ancient humans who mined uranium deposits have discovered the same phenomenon? Ancient mining operations across the world show evidence of selective mineral extraction. Miners didn't simply dig randomly. They targeted specific ores, distinguishing between different mineral types, with precision suggesting understanding of their properties. Some ancient mining sites in South Africa have been radiocarbon dated to over 100,000 years old, far predating accepted timelines for advanced mining. Why would pre-modern humans invest enormous labor in extracting specific minerals from deep underground unless those materials possessed recognized value beyond decoration? Ancient texts across cultures speak of gold in terms that seem excessive if describing mere decorative metal, gold of the gods, the flesh of gods, material with transformative powers. Perhaps gold was valuable not just for beauty, but as shorthand for radioactive elements, materials that glowed, emitted energy, and required careful handling. The Ark of the Covenant, described in biblical texts, killed those who touched it improperly. It emanated light. Handling protocols specified precise procedures, materials that could and couldn't contact it, and designated carriers who approached using specific techniques. These precautions mirror radiation safety protocols with remarkable consistency. While we cannot prove the Ark existed or verify its nature, the described handling procedures match exactly what you'd use around a radioactive device. Modern experimental research has documented the Hutchison effect, a controversial phenomenon where objects exposed to specific electromagnetic field combinations allegedly fuse, levitate, or transmute. Metal bars reportedly merge. Materials change properties. Orthodox physics struggles to explain these observations, and reproducibility remains contested. But read medieval alchemical texts, and you find descriptions of remarkably similar processes. Transmutation of base metals, fusion of substances under precise conditions, material transformation through application of forces described in symbolic language. Were alchemists preserving garbled knowledge of actual material science techniques, or creating elaborate mythology around failed experiments? Ancient texts describe weapons that sound exactly like nuclear bombs. Archaeological sites show radiation damage. What if those texts weren't mythology but history? What if the impossible technologies described in ancient writings preserved memories of civilizations that understood forces we think we discovered only in the 20th century? The evidence doesn't prove this conclusively, but it creates enough doubt to ask the question. If they understood energy at the atomic level, they would have needed advanced metallurgy, chemistry, and material sciences, and the evidence suggests they had exactly that. In the courtyard of the Qutb complex in Delhi stands a column of iron, 7 meters tall, erected around 400 CE during the Gupta Empire. Monsoon rains have pounded this pillar for over 1600 years. Humidity saturates the air during summer months. Temperature fluctuations stress the metal through endless cycles of expansion and contraction. By every principle of chemistry and metallurgy, this iron should be a corroded ruin, eaten away by oxidation long ago. Instead, the surface remains smooth, no rust, no corrosion. For 1,600 years, exposed to rain and humidity, the iron pillar stands without a trace of rust. Modern engineers can't explain how or why. When metallurgists finally analyzed samples in the late 20th century, they discovered the pillar contains 99.7% pure iron. Trace amounts of phosphorus distributed throughout the metal create a protective crystalline iron-hydrogen phosphate layer that shields the surface from oxygen and moisture. This protective coating forms naturally from the phosphorus content, but only if the iron remains exceptionally pure. Any significant impurities would disrupt the protective layer's formation, allowing rust to develop. Achieving such purity requires techniques Europe wouldn't develop until the modern industrial age. Yet it stands in Delhi, forged 15 centuries ago by craftsmen who supposedly lacked advanced metallurgical knowledge. Consider what creating this pillar demanded. High-grade iron ore, refined through multiple smelting stages to remove impurities. Furnaces reaching temperatures exceeding 1500 degrees Celsius, maintained long enough to process tons of raw material. Sophisticated forging techniques to shape the refined iron into a seamless 7-meter column without creating weak points or internal stresses that would promote corrosion. The skill level matches modern foundry work, accomplished with technology our history books classify as primitive. Was the rust resistance intentional or fortunate accident? Ancient Indian metallurgical texts, palm leaf manuscripts describing metal processing, contain references to preservation techniques that produce results matching the pillar's properties. They describe specific ore selection, multiple refinement cycles, and phosphorus addition for protection. The knowledge was deliberate, recorded, transmitted across generations. If Indians possessed such advanced metallurgy in 400 CE, this knowledge developed over centuries or millennia before that date, pushing sophisticated ironworking into periods we consider technologically crude. The pillar isn't alone. The Antikythera mechanism, recovered from a Roman-era shipwreck, contains bronze gears cast with precision, requiring molds accurate to fractions of millimeters. Viking swords from the 9th century display carbon nanotube structures in their steel microscopic formations, creating incredible strength and flexibility. Modern analysis revealed these nanotubes formed during forging, suggesting Vikings understood heat treatment processes that manipulate metal at molecular levels. Damascus steel, renowned for its distinctive wavy patterns and legendary sharpness, baffled metallurgists for centuries after its forging technique was lost. Only electron microscope analysis revealed the secret: carbon nanotubes and cementite nanowires distributed throughout the steel matrix. Medieval Syrian smiths created nanostructured materials 800 years before modern materials science understood such things were possible. In South African mines, workers discovered small metallic spheres in mineral deposits dated to 2.8 billion years ago, long before complex life existed on Earth. The spheres show perfectly concentric grooves around their equators, appearing machined rather than naturally formed. Geologists propose these formed through natural metamorphic processes, though the mechanism producing such precise features remains unclear. Alternative researchers suggest technological activity in the incomprehensibly distant past, though this explanation raises more questions than it answers. Each artifact sits in museums or archaeological sites, physically present, available for examination. These aren't theoretical reconstructions or disputed interpretations of ancient texts. They're objects you can touch, measure, analyze. The metallurgy is real. The techniques required are understood. What remains mysterious is how civilizations without our technology matched or exceeded our capabilities in specific areas. The iron pillar isn't alone. Across the ancient world, we find metalwork that shouldn't be possible. What techniques did they master that we've lost? In 1974, archaeologists excavating a tomb in Jiangxi province, China, discovered a belt buckle among grave goods dating to approximately 300 CE. The ornament appeared unremarkable until laboratory analysis revealed its composition. Aluminum. Pure aluminum. This metal wasn't isolated as an element until 1825, when Danish chemist Hans Christian Ørsted first extracted it. Industrial production didn't begin until 1886, when Charles Martin Hall developed the electrolytic process. Yet here sat an aluminum buckle in a 1700-year-old tomb, predating its supposed discovery by 15 centuries. The standard explanation suggests the buckle was a later intrusion, somehow introduced into the sealed tomb through disturbance or contamination. But the tomb showed no signs of breach. The buckle's corrosion patterns matched other artifacts from the burial, indicating similar age. If genuine, its presence forces recognition that ancient Chinese metallurgists extracted aluminum from bauxite ore, a process requiring electrolysis at temperatures exceeding 900 degrees Celsius. Using techniques conventional history claims weren't discovered until the late 19th century. Orichalcum existed only in legend. Plato described this golden-colored metal as second only to gold in value, used extensively in Atlantis for decorating temples and palaces. Scholars dismissed it as mythological invention until 2015, when divers exploring a 2,600-year-old shipwreck off Sicily recovered 39 ingots of a copper-zinc lead alloy, matching ancient descriptions perfectly. The metal glowed golden red. Chemical analysis proved deliberate, manufacturing precise temperature control and mixing ratios, creating an alloy whose formula had been lost for millennia. Someone knew exactly what they were creating, engineering a specific material through sophisticated metallurgical knowledge. In museums across South America sit platinum artifacts from pre-Columbian cultures. Small ornaments, nose rings, decorative objects crafted from platinum, a metal whose melting point reaches 1768 degrees Celsius. European metallurgy didn't achieve such temperatures until the 18th century with advanced furnace designs. Yet these artifacts exist, physically present, created by cultures whose technology we consider primitive. Either our assessment of their capabilities is fundamentally wrong, or they possessed heating methods we haven't recognized in the archaeological record. The Koso artifact generates fierce debate. Discovered in 1961 inside what appeared to be a 500,000-year-old geode, the object contained a ceramic component, copper spring, and iron core resembling a spark plug. Skeptics argue the geode formed rapidly around a modern object, that the dating was never properly verified, that the artifact is likely a 1,920 seconds automotive component, accidentally mineralized. But the original discoverers maintained their findings, and X-rays showed internal structure consistent with mechanical design. Whether genuine or misidentified, it represents a category of objects that don't fit comfortable chronological frameworks. Ancient jewelry displays techniques that seem impossible without precision tools. Granulation, fusing tiny gold spheres to surfaces without melting the base metal, requires temperature control within a few degrees. Etruscan jewelers mastered this 2,500 years ago. The technique was lost and only rediscovered in the 20th century through extensive experimentation. Filigree work shows precision, suggesting microscopic vision or magnification tools. Some ancient bronze artifacts, when analyzed, reveal alloy compositions that don't match standard bronze formulas, deliberately engineered metals whose recipes were lost when civilizations collapsed. Aluminum in a 1,700-year-old tomb. Platinum jewelry from cultures without furnaces hot enough to melt it. Either our dating is wrong, or they had technology we don't understand. Each artifact stands as physical challenge to accepted timelines. Museums store these objects, label them with careful academic language that acknowledges the mystery without resolving it. The metals are real. The compositions are verified. The manufacturing techniques are understood in principle, but historically impossible. Creating these alloys requires understanding chemistry at a level historians claim didn't exist. What other chemical secrets did they possess? Look closely at the limestone blocks forming the Great Pyramid. Conventional archaeology tells us workers quarried these stones, carved them to shape, and transported them across miles of desert. But French chemist Joseph Davidovits spent decades examining samples from ancient structures and discovered something that challenges this narrative. Under microscopic analysis, certain blocks contain air bubbles, tiny pockets of trapped gas that don't occur in natural stone. He found organic materials embedded in the matrix, mineral compositions inconsistent with quarried limestone, but perfectly consistent with artificial manufacturing. His conclusion sounds impossible. These stones weren't carved, they were cast. Davidovits proposed that ancient builders understood geopolymer technology, a form of synthetic stone making. Mix crushed limestone with alkaline solutions derived from natron or plant ash. Add water. The chemical reaction creates a moldable paste that hardens into material indistinguishable from natural rock. Pour this mixture into wooden molds and wait for it to cure. The result looks exactly like carved limestone, but was actually manufactured on site, eliminating the need to transport multi-ton blocks across vast distances. This theory explains mysteries that traditional archaeology struggles with. How did workers achieve perfect geometric shapes without visible tool marks? Molds ensure consistent dimensions. How do stones fit together with millimeter precision? No mortar required. Molds create standardized blocks. How were massive structures completed relatively quickly? Casting stones on site is faster than quarrying, transporting, and carving. The evidence sits in museum samples, visible under electron microscopes to anyone willing to look. Creating geopolymer concrete requires specific chemical knowledge, understanding alkaline solutions, mineral activation, binding agents, and curing processes. This isn't primitive trial and error. It's sophisticated materials science. Ancient texts across cultures reference stone softening techniques. Peruvian legends describe a plant juice that makes stone pliable, allowing builders to shape rock like clay. Mainstream archaeology dismisses these stories as mythology. But what if they preserve memory of actual chemical processes, described in metaphorical language by cultures that didn't use modern scientific terminology? Father Crespi, an Italian priest working in Ecuador during the 20th century, collected thousands of artifacts from local sources. Among them, metal plates covered with unknown writing systems, objects showing apparent advanced metallurgical techniques, items that don't fit accepted pre-Columbian technology levels. Critics claim these are modern forgeries sold to a naive collector. Supporters argue they represent evidence of sophisticated ancient cultures. Chemical analysis could definitively answer authenticity questions, but such testing faces restrictions from institutions controlling access to contested artifacts. Davidovits himself developed modern geopolymer concrete based on ancient formulas. His version surpasses Portland cement in strength and durability, while requiring significantly less energy to produce. This raises uncomfortable questions. If ancient formulas were superior to modern methods, what else did they understand that we've forgotten? How much knowledge was lost when these civilizations disappeared? In Scotland, archaeologists puzzle over vitrified forts, stone structures where walls were heated to temperatures exceeding 1100 degrees Celsius, fusing rock into glass. Whether this represents weaponry, construction technique, or evidence of violent destruction remains unknown. Achieving such temperatures requires either prolonged, intense fires or chemical processes that amplify heat beyond what wood or coal produces naturally. What if they didn't carve stones, they cast them? Ancient concrete technology lost for millennia, now only being rediscovered. The evidence is in the stones themselves, air bubbles that shouldn't exist. Chemical signatures indicating artificial manufacture, precision that makes sense only if molds were involved. The stones aren't lying, they're telling us exactly how they were made. We just weren't listening. Mastery over stone implies mastery over other materials. But perhaps their greatest achievement was controlling the element essential to all life, water. Beneath the deserts of Iran, an invisible network carries water from mountain sources to distant cities. These Kuanats, underground aqueducts, built 3,000 years ago, still function today, delivering steady flows through tunnels carved through solid bedrock. Stand at the surface, and you see only vertical shafts spaced at regular intervals, openings that punctuate the landscape in straight lines stretching for miles. But descend into the darkness, and you enter an engineering achievement that modern experts struggle to explain. The tunnels maintain a consistent downward gradient, precise enough to ensure water flows steadily without stagnating or eroding the channels. Too steep, and the water rushes destructively. Too shallow, and it pools, breeding contamination. The ancient engineers calculated slopes measured in inches per mile, maintained over distances exceeding 10 miles, all carved through underground rock where surveying instruments couldn't see the sun or stars for reference. Modern attempts to map these systems discover junction chambers where multiple tunnels meet, ventilation shafts positioned to ensure airflow, and filtering systems demonstrating deep understanding of hydrology and water purification. How did they survey these tunnels? What instruments allowed workers underground to maintain precise gradients they couldn't see or measure directly? The mathematics required calculating elevation changes, accounting for rock hardness variations, predicting water flow rates belongs to engineering disciplines formalized thousands of years later. Yet the Kuanats worked perfectly, sustaining cities across Persia for 3 millennia. Roman aqueducts inspire similar questions. The Pont du Gard in southern France rises 3 tiers above the Gardon River, stone arches supporting a channel that carried water for 2,000 years. Calculate the gradient. The aqueduct descends only 34 centimeters over its 50-kilometer length, less than 1 inch per mile. Achieving such precision requires surveying equipment and mathematical calculations matching modern civil engineering standards. But Romans didn't just move water downhill. They understood pressure differentials, building inverted siphons that pushed water upward through lead pipes, over valleys, and across terrain where gravity alone couldn't carry the flow. These hydraulic principles, using water pressure to overcome elevation changes, appear in Roman engineering centuries before physics formally described such mechanisms. The Great Bath of Mohenjo-Daro sits in ruins in modern Pakistan, but 4,500 years ago it functioned as a sophisticated hydraulic structure. Waterproofing layers of bitumen and fired brick prevented leakage. Drainage systems removed used water through covered channels, leading to settling tanks where solids separated from liquids before discharge. The city's sewage system included covered drains running beneath streets, inspection manholes for maintenance access, and evidence suggesting understanding of bacterial contamination knowledge that wouldn't return to European cities until the 19th century. Indoor plumbing connected homes to the municipal drainage network. Water and sewage never mixed. The Indus Valley civilization mastered urban sanitation millennia before London streets ran with sewage. At Angkor Wat in Cambodia, a complex system of reservoirs, channels and water management sustained a city of 1 million people in the 12th century. The Baray's massive rectangular reservoirs stored water through dry seasons, releasing it through gravitational flow to irrigate rice fields and supply the urban population. The system included filtration through sand beds, settling basins for sediment removal, and distribution networks that modern city planners study for their efficiency. The hydraulic engineering enabled urban density unmatched in medieval Europe, supporting a metropolis in tropical jungle through sophisticated water control. In Hierapolis, Turkey, archaeologists discovered remains of a water-powered stone-cutting mill operating in the 3rd century CE. Water from aqueducts turned wheels that drove saws through marble blocks, mechanizing construction in an era we consider pre-industrial. This represents the earliest known application of water power for industrial purposes, predating the Industrial Revolution's water mills by 1,500 years. The precision gearing, the power transmission mechanisms, the understanding of mechanical advantage, all exist in ruins we can examine today. They built tunnels miles long underground with perfect gradients, pushed water uphill without pumps, and created sewage systems that wouldn't be matched in Europe for 3,000 years. How? The structures stand as testimony. The calculations can be verified. The engineering principles are understood. What remains mysterious is how civilizations with supposedly primitive technology matched capabilities we associate with modern civil engineering. They controlled water with incredible precision. But was it just for drinking and irrigation, or did water serve other purposes we've forgotten? The Great Bath of Mohenjo-Daro measures 12 meters by 7 meters, descending nearly 2.5 meters into the earth. Workers lined it with fired bricks set in bitumen waterproofing, so effective it remained functional for centuries. Steps lead down from both ends into deep water. The construction involved enormous labor and sophisticated materials for what archaeology classifies as a public bath. But examine the precision. The waterproofing exceeds what simple bathing requires. The depth suggests purposes beyond hygiene. Was this a purification center where water held religious significance? A healing facility, exploiting water's therapeutic properties? Or perhaps something else entirely, a structure whose true function we've misidentified? Beneath the Temple of Dendera in Egypt, underground crypts contain elaborate hydraulic systems. Drainage channels carved through bedrock connect chambers at different levels. Water flowed through these passages following routes that seemed deliberately engineered rather than naturally formed. The purpose remains unknown. Traditional archaeology suggests ceremonial purification or practical drainage, but the complexity implies something more, a water-based mechanism whose function disappeared when the knowledge operating it was lost. In the Yucatan Peninsula, cenotes puncture the limestone landscape, natural sinkholes filled with groundwater that was sacred to the Maya. Archaeological dives recover jade, gold, and pottery thrown as offerings. But deeper exploration reveals something stranger. Underwater cave systems show evidence of modification. Carved passages, deliberate structures at depths exceeding 20 meters. Reaching such depths requires either remarkable breath-hold diving abilities or technology we don't associate with ancient Mesoamerica equipment, allowing sustained underwater work in complete darkness. Across Europe, holy wells mark sites chosen for more than water access. Many sit at locations with unusual geological properties. Underground springs emerging from specific rock formations, places where magnetic field measurements show anomalies, points where acoustic resonance creates unusual sound properties. Were these simply convenient water sources invested with religious meaning, or locations chosen because ancients detected properties we measure with instruments, electromagnetic fields, geomagnetic hotspots, or resonance frequencies affecting human consciousness? Beneath the Giza Plateau, the Osiris shaft descends through multiple levels cut from solid bedrock with precision. At the bottom, 30 meters down, a massive chamber floods with groundwater. Stone sarcophagi sit submerged in darkness. Orthodox Egyptology interprets this as a symbolic tomb representing the mythological burial place of Osiris. But the engineering seems excessive for symbolism. Multiple shaft levels, precisely cut rooms, a flooded chamber requiring constant water management, the structure suggests functionality beyond ritual. Some researchers propose it served as a hydraulic mechanism related to the pyramid above, part of the theoretical power plant system. Others believe it held purposes lost to history. Ancient texts across cultures describe waters of life, healing springs, and divine fountains. We read these as metaphor, poetic language describing ordinary water invested with religious significance. But what if they described actual facilities where water underwent processing using lost techniques? Modern research demonstrates that water's molecular structure responds to magnetic fields, vibration, and electrical current. Water exposed to specific frequencies shows measurable changes in properties. Scientists debate whether this affects biological systems, but the phenomenon is real. Did ancients understand these properties intuitively through observation, or scientifically through systematic investigation? Sacred wells, submerged chambers, and water temples built with impossible precision. What if water wasn't just for drinking but was a technology? A medium for energy transmission, a substance whose properties could be modified through techniques we've forgotten. The structures remain, their hydraulic sophistication undeniable. Their excessive engineering suggests purposes beyond what we recognize. Across every continent, we find the same obsession with mastering the elements. Water, sound, stone, metal, all harnessed with knowledge that vanished. Why? What happened? Every ancient culture remembers a flood. The Mesopotamians describe Utnapishtim surviving deluge in an ark. The Greeks tell of Deucalion and Pyrrha, sole survivors when Zeus flooded the earth. Hindu texts describe Manu warned by a fish to build a boat before waters consumed the world. Chinese mythology preserves the story of Gunyu taming catastrophic floods. Aztec cosmology describes the fourth sun ending in flood. Australian Aboriginal traditions speak of the time when seas rose and drowned the land. Norse mythology tells of the deluge following Ragnarok. Over 200 cultures worldwide preserve flood narratives describing devastation that destroyed previous civilizations. We're taught these are independent inventions, universal myths arising because floods are common natural disasters, but the details align too precisely. A global or near-global catastrophe. Advanced civilizations destroyed, few survivors, a world ending and new world beginning. What if they're not telling the same story, they're remembering the same event? Geological evidence confirms that approximately 11,600 years ago, at the end of the last ice age, sea levels rose rapidly. Melting ice sheets released unimaginable volumes of water. Oceans rose over 400 feet. Coastlines where ancient populations concentrated disappeared beneath waves. This wasn't gradual change spread across millennia. Evidence suggests pulses of rapid rise, catastrophic flooding events, when ice dams broke, releasing enormous volumes of glacial meltwater in geological instants. Underwater archaeology reveals what was lost. Submerged structures off the coasts of India, Japan, and the Mediterranean. Stone formations showing clear signs of human construction, now resting beneath hundreds of feet of water. These weren't primitive settlements. Some show sophisticated engineering, megalithic construction, and urban planning. The flood legends weren't exaggerating. Cities vanished beneath rising seas. But sea level rise alone doesn't explain the suddenness described in myths. The Younger Dryas impact hypothesis proposes that around 12,800 years ago, a cosmic impact, possibly a fragmenting comet, struck Earth. The evidence appears in geological strata worldwide, a thin layer containing platinum and nanodiamonds, signatures of extraterrestrial impact. This impact would have caused rapid climate change, triggered megafauna extinctions, and disrupted human civilizations. The event marked the beginning of the Younger Dryas Cold Period, an abrupt return to glacial conditions lasting over 1,000 years before warming resumed. If an advanced coastal civilization existed during this period, the impact would have been catastrophic. Tsunami waves from ocean impacts, wildfires from atmospheric heating, climate collapse. Then, as temperatures eventually warmed and ice melted, the final blow, rising seas, inundating the coastal centers where their cities stood. Plato's account of Atlantis describes exactly this, a technologically advanced civilization destroyed by earthquake and flood. He dates the event 9,000 years before his time, approximately 9,600 BCE. This corresponds eerily with the Younger Dryas period. Mainstream scholarship dismisses Atlantis as philosophical allegory, but what if Plato preserved genuine historical memory transmitted through Egyptian priests who preserved knowledge of the catastrophe? Göbekli Tepe in Turkey was built around 9,600 BCE by people archaeology classifies as primitive hunter-gatherers. Yet they created megalithic temples with sophisticated astronomical alignments, carved pillars depicting advanced symbolic systems, and moved stones weighing tons without metal tools or wheels. The conventional explanation struggles, but if these builders were survivors of a destroyed civilization, the site makes sense, refugees preserving fragments of lost knowledge through permanent monuments. Cultural amnesia happens faster than we imagine. Within 3 generations, traumatic events become distorted. Within 10, they transform into myth. A technologically advanced civilization destroyed by catastrophe would lose most knowledge within centuries. Survivors scattered to inland areas would preserve fragments through oral tradition, slowly degrading into the flood myths we dismiss as primitive superstition. But they were remembering something real. Not everything was destroyed. Knowledge survived in secret, preserved by those who understood its power, and they made sure it would be rediscovered when humanity was ready. For nearly 2,000 years, the Eleusinian mysteries operated outside Athens, drawing initiates from across the ancient world. Kings, philosophers, generals, and commoners underwent secret rites promising profound transformation. Participants took vows of silence so seriously that despite the mysteries functioning continuously from approximately 1,500 BCE to 392 CE, no detailed accounts of the central ceremonies survive. What was revealed in those torchlit underground chambers? What knowledge transformed participants so completely that they considered death preferable to breaking their oaths? The silence held. Even as empires rose and fell, even as religions replaced old gods, even under Roman persecution and Christian prohibition, no one spoke. This wasn't primitive superstition. These were educated people, many literate, many powerful enough to face no consequences for revelation. Yet they remained silent. The knowledge must have been profound enough, dangerous enough, or sacred enough to justify absolute secrecy across generations. What could inspire such dedication? The Egyptian mystery schools offer clues. Temple priests underwent training lasting decades, studying mathematics, astronomy, medicine, sacred geometry, and spiritual practices. According to historical accounts, Pythagoras spent 22 years studying in Egyptian temples before returning to Greece. Plato traveled to Egypt, as did Solon and other philosophers credited with founding Western intellectual tradition. They didn't invent their knowledge. They learned it from priests who preserved older wisdom knowledge. Those priests inherited from predecessors, reaching back into eras before written history. This suggests classical Greek civilization didn't emerge through spontaneous genius, but through transmission of Egyptian science that was itself inherited from even earlier sources. The Greeks get credit for discovering mathematical principles, philosophical concepts, and astronomical knowledge they actually acquired through Egyptian initiation. The mystery schools weren't teaching religion alone. They were preserving scientific and technical knowledge disguised in spiritual language to restrict access to qualified students. The Library of Alexandria attempted something unprecedented, gathering all human knowledge into one institution. It wasn't merely a library, but a research center, translation facility, and knowledge repository. Scholars traveled from across the known world to study there. Texts in dozens of languages were collected, translated, catalogued. How many ancient technical manuals sat on those shelves? How many accounts of pre-flood civilizations? How many descriptions of lost technologies? We'll never know. The library burned. Not once, but repeatedly. Julius Caesar's forces, Christian mobs, Arab conquest. Each burning erased irreplaceable knowledge. What survived represents fragments of what once existed. Knowledge preservation doesn't require writing. Australian Aboriginal songlines encode geographical, astronomical, and survival information in chants transmitted for thousands of years. Recent research proves these oral traditions contain accurate historical information about coastal geography from when sea levels were lower during the Ice Age, over 10,000 years of reliable data transmission without written records. The songs describe landmarks now underwater, routes now flooded, knowledge preserved through pure oral tradition, with remarkable accuracy. Western academics dismissed oral traditions as unreliable until forced to acknowledge their precision. What else did we dismiss that actually encoded real information? The myths we consider primitive fantasy might preserve sophisticated knowledge in symbolic form. Hermeticism, attributed to Hermes Trismegistus, describes principles of natural law that sound mystical but may encode scientific observations. As above, so below suggests fractal patterns in nature, a principle confirmed by modern physics, showing self-similar structures from quantum to cosmic scales. Hermetic texts discuss transmutation, correspondence, and the interconnection of all things, using spiritual language that could describe chemistry, energy, and quantum entanglement. Alchemical manuscripts use elaborate symbolic systems. Surface reading suggests magical thinking turning lead to gold through mystical processes. But examine the symbolism closely, and chemical procedures emerge. Gold represents spiritual enlightenment in metaphor, but texts also describe literal metallurgical transformations using coded language. Why the secrecy? Perhaps to restrict dangerous knowledge to qualified practitioners. Perhaps to preserve information during periods when such knowledge would be persecuted as heresy. For thousands of years, they kept secrets so important that initiates chose death over revealing them. What knowledge was worth protecting with such absolute silence? The mystery schools operated for millennia, carefully selecting and training new generations of knowledge keepers. The pattern existed: worldwide Egyptian priests, Greek mysteries, Vedic traditions, shamanic lineages. All preserved wisdom through restricted transmission, requiring years of preparation before revealing deeper teachings. The mystery schools ended, or so we're told. But did the pattern of hidden knowledge really stop, or did it just change form? Archaeology operates according to established frameworks. Findings must fit accepted timelines. Methodologies follow peer-reviewed standards. Discoveries that don't conform to established chronologies face intense skepticism, not because archaeologists are closed-minded, but because extraordinary claims require extraordinary evidence, and academic careers depend on maintaining credibility within professional communities. The result is institutional conservatism that interprets ambiguous evidence in ways supporting existing theories rather than prompting revolutionary revision. Consider artifacts suggesting advanced ancient capabilities. When they surface, the pattern repeats. Initial excitement, followed by reinterpretation fitting conventional models, then eventual dismissal or burial in museum storage. The Baghdad battery generates measurable current, yet remains classified as a scroll container. The aluminum buckle from ancient China sits in a collection, its implications unexamined. Sites showing evidence of advanced engineering receive minimal funding for further investigation because grants flow to projects fitting established narratives. The Burroughs Cave in Illinois reportedly contained thousands of artifacts, showing Old World contact with pre-Columbian America, inscribed stones, metal objects, evidence of Mediterranean civilizations reaching North America millennia before Columbus. Either this represents one of archaeology's greatest discoveries, or an elaborate hoax perpetrated on naive collectors. Mainstream archaeology won't investigate definitively. Testing the artifacts would resolve the question, but institutional reluctance leaves it hanging in limbo, too controversial to examine, too problematic to ignore, so it sits unresolved. Why won't institutions conduct thorough testing of controversial artifacts? Chemical analysis of the Baghdad battery's corrosion deposits could confirm ancient use. Geological surveys of erosion patterns on the Sphinx could establish construction dates. Detailed analysis of the aluminum buckle's crystalline structure could verify age. These tests are technically feasible and relatively inexpensive, but they're not performed. Perhaps because confirming the artifact's authenticity would require rewriting chronologies, admitting previous interpretations were wrong, and facing professional consequences. Researchers who challenge accepted timelines risk their careers. Graduate students learn quickly which questions are safe to ask. Junior faculty seeking tenure avoid controversial topics. Funding committees favor conventional projects with predictable outcomes. Academic journals prefer confirmatory studies over revolutionary findings. The incentive structure systematically discourages investigation of anomalous evidence. Fringe claims and obvious hoaxes compound the problem. Ancient aliens theories, crystal skull mysticism, and elaborate fabrications make legitimate questions easier to dismiss through guilt by association. The professional cost of being linked to pseudo-archaeology means serious researchers avoid these topics entirely. Anyone questioning conventional chronologies gets lumped with conspiracy theorists, making rational discussion nearly impossible. Repatriation politics complicate matters further. Indigenous groups and source countries restrict access to artifacts and sites, sometimes preventing analysis that might reveal uncomfortable truths about cultural origins, technological capabilities, or historical interactions. These restrictions serve legitimate interests, protecting sacred sites, reclaiming stolen heritage, resisting colonial exploitation. But they also limit investigation of questions that might expand understanding of human history. The Vatican archives contain millions of documents unavailable to researchers, some dating back centuries. What historical records might they preserve about ancient technologies, suppressed gospels, or pre-Christian knowledge systems? Access is severely restricted. Researchers can request specific documents if they know exactly what to ask for, but browsing is impossible. How much relevant information sits in those climate-controlled vaults, catalogued in ways that obscure significance? This isn't conspiracy. No secret cabal meets to suppress truth. The barriers are structural career incentives, funding priorities, institutional inertia, and the simple human tendency to interpret ambiguous evidence in ways confirming existing beliefs. The system doesn't deliberately hide knowledge. It just makes investigating certain questions professionally dangerous and practically difficult. Academic careers destroyed for asking wrong questions. Artifacts dismissed without testing. Sites reburied without excavation. Not conspiracy, just institutional inertia that refuses to see what doesn't fit. Throughout history, knowledge has been controlled, but some secrets escaped. Some truth was encoded where it couldn't be erased in monuments, myths, and traditions that survived every attempt to destroy them. They built monuments that would outlast any catastrophe, encoding knowledge in stone that would survive until humanity was ready to understand. The messages are still there, waiting to be decoded. Consider the sheer mass of megalithic structures. We're told they were built through religious devotion, expressions of faith in gods now forgotten. But what if the scale itself was the point? Paper burns. Bronze corrodes. Even entire civilizations collapse into dust. Stone endures. When you want to preserve knowledge across millennia, through whatever might come, you carve it into something that cannot easily be erased. The ancient builders encoded information in three fundamental ways: alignment, proportion, and symbol. Astronomical alignments preserved their understanding of celestial mechanics. Mathematical proportions embedded constants and principles into physical form. Symbols carried cultural and spiritual concepts forward through time. Each monument functioned as a multi-layered text, readable by those who learned its language. The Sphinx presents one of archaeology's most uncomfortable puzzles. Researcher John Anthony West spent decades documenting its weathering patterns, and what he found challenges everything. The erosion on the Sphinx and its enclosure shows clear signs of water damage, not wind erosion, which dominates Egypt's current desert climate, but heavy, sustained rainfall. In Egypt's present conditions, such rainfall hasn't occurred since around 10,000 BCE, long before any accepted timeline of Egyptian civilization. Either the Sphinx is far older than we believe, or Egypt's climate was radically different during what we call the historical period. Neither option fits comfortably into conventional chronology. Graham Hancock expanded this puzzle into a global pattern. He proposed that megalithic sites worldwide form a coordinated message system, encoding coordinates, star maps, and warnings about cyclic catastrophes. These weren't isolated projects by disconnected cultures. They were pieces of a larger communication, built by survivors trying to ensure their knowledge wouldn't die with them. The monuments speak to each other across continents and millennia, preserving a map of cosmic events that repeat on timescales longer than civilizations typically survive. The Mayan long count calendar, ending in 2012, sparked apocalypse fears, but the Maya themselves never predicted world destruction. They marked the completion of a great cycle and the beginning of another 13 Baktuns, roughly 5,125 years. This suggests they understood cosmic or geological cycles affecting Earth on timescales beyond individual human experience. They built their calendar not to predict the end, but to mark rhythms larger than empires. The encoding methods were sophisticated. Monuments aligned to cardinal directions with precision modern builders struggle to match. Specific stone types were chosen for particular properties: resonance, durability, electromagnetic characteristics. Mathematical constants appear embedded in dimensions: pi in the Great Pyramid's ratios, phi in Stonehenge's proportions. Astronomical alignments track precession, solstices, stellar events that mark cosmic time. Every element carried meaning. The Georgia Guidestones, before their destruction in 2022, demonstrated this concept's modern relevance. Erected in 1980, they attempted to preserve basic principles for rebuilding civilization after catastrophe: population limits, environmental balance, reason over superstition. Whatever you think of their message, they proved the monument as time capsule idea remains compelling. Some knowledge matters enough to carve in stone. Ancient megalithic art shows remarkable consistency across continents: spirals, concentric circles, zigzag patterns, geometric designs. We've dismissed these as decoration, primitive aesthetic choices. But archaeoastronomy reveals correlations between these symbols and astronomical observations. Spirals represent galaxies or solar systems. Concentric circles map orbital paths. Zigzags track the ecliptic or solar activity patterns. These weren't merely decorative, they were visual language encoding observational data. The question becomes, what else is encoded that we haven't yet learned to read? Every monument holds layers of information, some obvious, others waiting for the right interpretive key. For centuries, these messages were dismissed as primitive art, the work of cultures we assumed had nothing to teach us. But as our technology advances, we're finally beginning to read what they left behind. Every year, new technology reveals lost cities, hidden chambers, and impossible achievements we missed for centuries. The more we look, the more we realize they knew. LiDAR changed everything. Light detection and ranging, essentially laser scanning that penetrates jungle canopy to map the ground beneath. For decades, archaeologists walked past ruins hidden under vegetation, never realizing entire cities lay buried under their feet. Then LiDAR arrived, and the jungle gave up its secrets. In 2019, researchers scanned northern Guatemala. The LiDAR revealed a Mayan megalopolis covering 810 square miles, not scattered villages. A continuous urban network housing millions, connected by elevated causeways, featuring pyramids, palaces, fortifications, agricultural terraces, and irrigation systems. The Maya weren't primitive corn farmers occasionally building temples, they were urban planners managing infrastructure at a scale matching Rome at its height. Similar discoveries followed in Cambodia near Angkor Wat, in the Amazon where cities were thought impossible, in Honduras where valleys once considered empty now showed dense settlement. The jungle hadn't reclaimed these places. It had hidden them while we assumed there was nothing to find. Ground-penetrating radar tells another story beneath monuments we thought we understood. Giza, Teotihuacan, Stonehenge radar reveals chambers, tunnels, voids we never suspected. We've explored surfaces for centuries, while entire subterranean complexes waited below. Each scan suggests our excavations have barely scratched the surface. What we call complete archaeological sites are merely the portions we've accessed. The rest remains sealed, waiting. Materials analysis reveals sophistication hidden in plain sight. Damascus steel, legendary for its strength and distinctive wavy patterns, was examined under electron microscopes. Researchers found carbon nanotube structures embedded in the metal, the same nanostructures modern materials scientists engineer deliberately for advanced applications. These nanotubes form naturally during Damascus steel's forging process, but only under extremely precise conditions. Temperature must be controlled within narrow ranges. Cooling rates must follow specific curves. The margin for error is minimal. Medieval smiths consistently achieved results that require exactness we associate with modern manufacturing. They understood metallurgy at a level formal science didn't describe until centuries later. Archaeoacoustics opened another window into ancient knowledge. Researchers scan ancient spaces, theatres, temples, tombs, creating acoustic models showing how sound behaves in these environments. The Rochester Institute of Technology mapped numerous sites, and the results were startling. Ancients designed spaces with reverberation times, matching modern concert halls. They built chambers focusing sound at specific points, with precision that requires understanding acoustic principles formerly described only in the 20th century. The oracle chamber at Delphi amplifies voices at particular frequencies while dampening others, creating effects that would seem supernatural to those unaware of acoustic engineering. They weren't stumbling into these properties accidentally. They were engineering them deliberately. Computer modeling tests theories we accepted for generations. How were pyramids built? Ramp theories seemed logical until researchers modeled them precisely. The ramps would require more material than the pyramids themselves. They don't work at the necessary scale. Alternative methods, internal ramps, counterweights, lever systems work in models, but require coordination and mechanical understanding exceeding what we attributed to Bronze Age civilizations. Either our timeline is wrong, or their capabilities were far greater than assumed. The models force uncomfortable conclusions. Satellite archaeology reveals patterns invisible from ground level. Infrared imaging detects crop marks where ancient walls altered soil composition. Multispectral analysis shows roads, irrigation networks, territorial boundaries that naked eyes miss. In Egypt, satellites revealed 17 lost pyramids. In Peru, they mapped geoglyphs spanning hundreds of miles. In Italy, they found buried Roman roads, forming networks more extensive than historical records suggested. Each discovery reveals planning and organizational capacity, demonstrating advanced administrative and engineering sophistication. The pattern becomes clear. Ancient civilizations weren't primitive predecessors struggling toward enlightenment we eventually achieved. They possessed knowledge that modern technology is only now allowing us to recognize. Every advancement in our scanning, modeling, and analysis capabilities reveals another layer of their achievement we previously missed. We're not just finding lost cities, we're rediscovering lost sciences. Principles that ancients understood, but we had to reinvent from scratch. Quantum physics sounds like ancient mysticism. Consciousness research validates what shamans knew 10,000 years ago. Maybe they weren't primitive, maybe we're just finally catching up. At the quantum level, observation affects reality. Particles exist in superposition until measured, then collapse into definite states. The observer's act of observing changes what's observed. This isn't metaphysics, it's demonstrated physics. Ancient mystics said, consciousness creates reality, that thoughts shape the world. Modern physics discovered the observer effect. The language differs, but the concept aligns uncomfortably well. The placebo effect reveals mind affecting matter. Patients given inert substances show measurable healing when they believe they've received real medicine. Pain decreases, inflammation reduces, symptoms improve, all from expectation alone. Ancient healing practices emphasized ritual, belief, and mental state as much as physical treatment. We dismissed this as superstition until controlled studies proved that belief and expectation produce biological changes. What we called primitive psychology turns out to be applied psychophysiology. Meditation research goes further. Regular practice doesn't just calm the mind, it restructures the brain. Grey matter increases in regions controlling attention and emotion regulation. Gene expression changes, affecting inflammation and immune response. Telomere length increases, literally slowing cellular aging. Mental practice alone produces measurable biological transformation. Monks weren't escaping reality through meditation. They were engineering their neurology. Cymatics demonstrates something ancient temples suggested. When sound vibrations pass through water or sand, they create geometric patterns, spirals, hexagons, mandalas. The patterns depend on frequency. Different tones produce different forms. Sacred geometry carved into ancient structures mirrors these cymatic patterns exactly. The ancients claimed sound and form were connected. that certain frequencies held special properties. Cymatics shows they were describing observable physics. Biofield research measures what energy healers claim to sense. Human bodies emit electromagnetic fields. Heart rhythm, brain activity, and physiological states all generate measurable electrical signatures. Studies show trained practitioners can detect these fields, and that focused intention correlates with changes in recipients' physiological measures. Qigong, Reiki, pranic healing practices, dismissed as theatre show effects in controlled conditions. The mechanisms remain debated, but the measurements exist. Princeton's Global Consciousness Project ran random number generators worldwide, looking for deviations from randomness during major events. When millions of people focus attention simultaneously during disasters, celebrations, to global moments, the data shows statistically significant patterns. The effect is small, but consistent across decades of data. Human consciousness may have collective, non-local properties. Every ancient tradition said this. Science is measuring it. Water memory research remains controversial. Studies suggest water's molecular structure can retain information, that structured water has different biological properties than ordinary water. Mainstream science largely rejects this, but research continues. Ancient concepts of blessed water, living water, sacred springs, having special properties suddenly sound less absurd. The mechanisms aren't established, but the questions have moved from impossible to unexplored. Breathing techniques from ancient yoga and meditation traditions are being studied for physiological effects. Controlled breathing affects nervous system regulation, inflammatory markers, and immune response. Specific patterns produce specific results: activation or calming, focus or relaxation. Pranayama wasn't superstition. It was systematic manipulation of autonomic nervous system function through rhythmic breathing patterns. Psychedelic research reveals why ancient ceremonies used these compounds. Psilocybin, ayahuasca, and similar substances produce neuroplasticity, the brain's ability to form new connections. They decrease default mode network activity, the mental patterns creating our sense of separate self. Users report mystical experiences, ego dissolution, lasting psychological benefits. Ancient shamans didn't have neuroscience degrees, but through millennia of empirical observation, they identified compounds producing specific consciousness states with therapeutic and transformative properties. They were practical neurochemists. The pattern is consistent. Ancient wisdom that sounded like superstition shows measurable effects when examined scientifically. They knew things we're only now learning to test properly. If they knew all this, where did the knowledge come from? How did ancient civilizations, supposedly primitive, develop such sophisticated understanding? Where did the knowledge come from? A lost civilization that reached heights we're still struggling to match? Or something else entirely, something we're not ready to accept? The lost civilization hypothesis presents a compelling framework. An advanced global culture existed before 10,000 BCE, possessing sophisticated technology in astronomy, mathematics, engineering, and possibly more. Cataclysmic events, Younger Dryas impacts, floods, radical climate shifts destroyed this civilization almost entirely. Survivors scattered across continents, carrying fragments of knowledge that seeded later cultures. This explains why Egyptian, Sumerian, and Harappan civilizations appear fully formed in the archaeological record, with writing systems, complex mathematics, and monumental architecture emerging without apparent gradual development. They didn't start from scratch, they inherited. The independent development theory offers the mainstream counter. Human innovation capacity exceeds our assumptions. Given enough time, observation, and experimentation, separate cultures independently discovered similar principles. Mathematics is universal. Any civilization developing geometry will find the same ratios. Astronomy rewards patient observation. Anyone watching skies for centuries will map the same patterns. This position holds academic consensus, but struggles explaining specific similarities. Why do geographically isolated cultures build pyramids, using nearly identical angles? Why do their mythologies describe remarkably similar cosmic cycles and catastrophic floods? Independent discovery explains parallel principles. It doesn't easily explain parallel details. Intervention theories exist at the edge of acceptable discourse. Ancient astronaut hypotheses propose extraterrestrial contact transmitted knowledge to primitive humans. Other versions suggest interdimensional entities, time travelers, or civilizations we have no framework to categorize. The narration here requires care. These ideas fall outside current scientific paradigms, but history shows paradigms shift when evidence demands it. We present without endorsement, noting that many ancient accounts explicitly describe knowledge coming from external sources, gods, sky beings, civilizers arriving from elsewhere to teach agriculture, astronomy, architecture, and law. Evidence exists supporting various interpretations. Genetic studies reveal population bottlenecks around 70,000 years ago and again near 12,000 years ago. Something reduced human populations dramatically, events catastrophic enough to leave genetic signatures visible today. Mythological accounts worldwide describe similar events: great floods, fire from the sky, ages of darkness when the world nearly ended. Cultures separated by oceans tell versions of the same story. Anomalous artifacts challenge chronological assumptions. Objects found in geological strata where they shouldn't exist. Technologies appearing in cultures supposedly lacking the capability to produce them. Precision in ancient construction exceeding what their presumed tools should allow. Each case is debated, often dismissed, but the accumulation suggests our timeline contains gaps we haven't explained. The similarities between distant ancient cultures remain striking. Pyramids in Egypt, Mexico, Cambodia, and Peru, built by cultures with no known contact, yet sharing architectural principles and astronomical alignments. Sacred geometry appearing in temples from different continents, same ratios, same symbolic systems, same understanding of proportion and cosmic order, star maps showing identical constellations marked as significant. Either these similarities result from universal human tendencies discovering universal truths, or something connected these cultures in ways we haven't recognized. The truth likely resides in complexity, not simplicity. There may have been predecessor civilizations more advanced than accepted chronology allows. There certainly was independent innovation, human ingenuity, operating across millennia. And there may be aspects of history, consciousness, or reality itself that future discoveries will illuminate in ways current frameworks don't anticipate. We stand at a peculiar moment. Technology reveals what previous generations missed. Ancient sites yield new data. Our understanding evolves, often in directions that validate questions once dismissed as fringe speculation. The mystery deepens as knowledge increases. Whatever the source, one truth remains: ancient knowledge is being rediscovered, and the question isn't where it came from but what we do with it now that we're finding it again. Every year, we rediscover another ancient technique that works better than our modern methods. They weren't primitive, we're just stubborn learners, relearning lessons they mastered long ago. Biomimicry sounds cutting edge, but it's ancient practice rebranded. Studying nature's designs to solve engineering problems, this is how builders worked before we decided we knew better. The Eastgate Center in Zimbabwe maintains comfortable temperatures without air conditioning by mimicking termite mound ventilation. Termites perfected this system over millions of years. Ancient architects used identical principles, orienting structures to catch prevailing winds, creating thermal mass that absorbed heat during day and released it at night, designing spaces where air flowed naturally without mechanical systems. We abandoned these methods for energy-intensive climate control, then called it innovation when we returned to what never stopped working. Joseph Davidovits reverse-engineered ancient concrete formulas and created geopolymer cement stronger, more durable, and less environmentally damaging than Portland cement dominating modern construction. Then, he found evidence the ancients used similar technology. Roman concrete, still standing after 2,000 years, uses volcanic ash in ways creating molecular structures that strengthen over time. Modern concrete crumbles within decades. We thought we'd advanced. We'd actually regressed, losing knowledge that produced superior results. Sacred geometry returned through architecture and design. The golden ratio, Fibonacci sequences, and specific proportional systems create aesthetically pleasing and structurally sound designs. Research shows these ratios appear throughout nature and resonate with human perception in measurable ways. Ancient builders employed these principles systematically. Gothic cathedrals, Greek temples, Egyptian pyramids all incorporate mathematical relationships shown to produce psychological and physiological responses in occupants. Modern architects dismissed this as mysticism until studies confirmed the effects. Now they're reintegrating proportions that ancient builders never abandoned. Water treatment technology discovered that vortex flow patterns naturally purify and structure water. Spiral motion creates conditions that reduce contaminants, increase oxygenation, and alter molecular structure in ways affecting biological properties. Ancient aqueducts incorporated curved channels, spiral features, and flow patterns, creating these effects without understanding the precise mechanisms. They observed results and built accordingly. We replaced their systems with chemical treatment and linear pipes, then rediscovered that their approach worked better. Sound healing research validates frequencies ancient temples encoded acoustically. 528 Hz affects DNA repair mechanisms. 432 Hz produces measurable relaxation responses. 110 Hz induces altered consciousness states. When researchers mapped acoustic properties of ancient temples, these exact frequencies appeared designed into the architecture. Chambers resonated at specific pitches. Chanting and instruments amplified at particular tones. They weren't decorating spaces, they were engineering acoustic environments for therapeutic and consciousness-altering purposes. Regenerative agriculture rediscovers techniques proving more sustainable than industrial methods. Amazonian terra preta soil, created through deliberate charcoal incorporation, remains fertile centuries later, while surrounding jungle soil depletes rapidly. Medieval three-field rotation systems maintained productivity without chemical fertilizers. Pre-Columbian Three Sisters, planting corn, beans, squash, grown together, create symbiotic relationships where each plant supports the others, reducing pest pressure and maximizing yield per acre. Industrial agriculture treats these as quaint historical practices while confronting soil depletion, chemical dependence, and ecosystem destruction. The old methods work better long-term. We're slowly admitting this. Traditional medicine faces scientific examination and often validates ancient understanding. Ayurvedic approaches to diet, lifestyle, and herbal intervention show measurable effects in clinical studies. Traditional Chinese medicine's acupuncture points correlate with fascia intersections and nerve clusters. Indigenous healing plants contain compounds. Pharmaceutical companies now extract and patent. The knowledge was preserved through oral tradition and practical application for millennia. Western science dismissed it as superstition, then began confirming it piece by piece through controlled studies. Meditation, yoga, and breathwork moved from fringe practices to mainstream adoption as research confirmed benefits. Meditation restructures brain networks, controlling attention and emotion. Yoga improves flexibility, strength, and nervous system regulation. Breathwork affects stress response, inflammation, and immune function. Ancient practitioners developed these technologies through empirical observation over thousands of years. Modern science needed brain scanners and controlled trials to accept what practitioners already knew worked. The pattern repeats across domains. Ancient technique dismissed, modern alternative promoted. Studies eventually show ancient methods superior. Gradual reintegration begins. We're not discovering new knowledge. We're remembering what was forgotten. These aren't isolated techniques. They're pieces of a larger understanding, a worldview where everything connects, where ancient and modern aren't opposites, but partners in understanding reality. What if human history isn't a straight line from primitive to advanced, but a spiral returning to ancient truths with new understanding? What if the future requires remembering the past? The dominant paradigm presents history as linear progress. Primitive humans evolved into civilized societies. Technology advanced steadily. Knowledge accumulated directionally. We stand at the pinnacle, looking back at less developed ancestors who lacked our capabilities. This narrative feels intuitive because it flatters us. We're the culmination, the achievement, the validation of everything that came before. Ancient achievements challenge this comfortable story. If civilizations 10,000 years ago possessed astronomical knowledge we only recently rediscovered, if they built structures we still can't fully replicate, if their medical and architectural understanding surpassed what followed for millennia, then history isn't linear, it's cyclical. Civilizations rise and fall, knowledge is gained and lost. Progress isn't guaranteed, it must be consciously maintained, or it disappears. This shifts how we evaluate modern technology. Are smartphones more advanced than acoustic levitation? Is the internet superior to consciousness-altering architecture? We have different capabilities, not necessarily better ones. A civilization that could move massive stones without machines, that built structures aligned to celestial mechanics without computers, that developed medical treatments we're only now validating scientifically, was that civilization less advanced or differently advanced? The question becomes uncomfortable because it undermines assumptions about our superiority. The concept of appropriate technology offers another lens. Perhaps ancients developed tools perfectly suited to their needs and understanding, sustainable over millennia rather than extracting maximum power regardless of long-term consequences. Stone construction lasted thousands of years. Our buildings crumble within decades. Their agriculture sustained populations without depleting soil. Ours requires chemical inputs that poison ecosystems. Different priorities produce different outcomes. Theirs prioritized endurance. Ours prioritizes immediate productivity. Neither approach is objectively superior. They reflect different values. Recognizing ancient sophistication dismantles Eurocentric historical narratives, positioning Western civilization as humanity's apex. The global story reveals non-European cultures leading in mathematics, astronomy, medicine, and engineering. Arabic scholars preserved Greek knowledge through Europe's Dark Ages and advanced it further. Chinese innovation in metallurgy, printing, and navigation preceded European versions by centuries. Mesoamerican astronomical calculations exceeded European accuracy. Indian mathematicians developed concepts zero, infinity, negative numbers that revolutionized mathematics. The narrative of Western exceptionalism requires ignoring most of human achievement. Psychological resistance to these ideas runs deep. Acknowledging ancient sophistication threatens identity narratives about cultural superiority and inevitable progress. If we're not the pinnacle, if previous eras knew things we've forgotten, then our self-conception as history's most advanced civilization collapses. That collapse feels threatening because it suggests we might lose what we have, that our knowledge isn't secure, that regression remains possible. Academic institutions and education systems have invested enormous resources maintaining particular historical narratives. Admitting fundamental errors would require restructuring curricula, revising textbooks, reconsidering careers built on now questionable assumptions. Institutional inertia isn't mere stubbornness. It's protecting investments of time, reputation, and resources. Change comes slowly because acknowledging error costs much. Temporal provincialism describes our assumption that this time period represents the pinnacle of human knowledge and capability. We can't imagine previous eras knowing things we've forgotten. This mirrors geographic provincialism, where cultures assume their way is the only sophisticated way. Both provincialisms stem from the same error, mistaking familiarity for superiority. Assuming what we know defines what's knowable. True advancement comes from synthesis. Integrating ancient wisdom with modern discovery, recognizing that different times and cultures develop different aspects of understanding, drawing from all sources rather than privileging one tradition. Comprehensive knowledge requires humility, admitting we don't know everything, that others knew things worth recovering, that progress sometimes means looking backward to move forward. This isn't just abstract history. What ancient knowledge means for you, personally, right now, as you navigate life in a world that's remembering what it forgot. They built these monuments for you. The knowledge was encoded, preserved, and hidden, waiting for the moment when humanity would be ready to remember. That moment is now. You are here because you're ready. This isn't just history you're absorbing. It's invitation. You have a role in preserving and advancing knowledge that ancient civilizations fought to protect. That role begins with questioning accepted narratives. When authorities claim something is settled, when textbooks present one version as fact, when mainstream voices dismiss alternative explanations without examination, that's when curiosity matters most. Your willingness to ask uncomfortable questions keeps possibilities alive that institutional inertia would bury. Practical participation takes many forms. Understanding ancient acoustic principles might inform your music, your sound healing work, your relationship with vibrational frequency. Sacred geometry can guide creative projects, architectural designs, or simply how you arrange space in your home. Meditation and consciousness practices preserve ancient inner technologies, methods for exploring awareness that don't require external tools. Studying archaeology, alternative history, and fringe theories keeps questions circulating when academic gatekeepers would close them. Every person who maintains open-minded curiosity becomes a vessel for knowledge-seeking expression. The internet, ironically, humanity's most modern technology, enables decentralized knowledge preservation, echoing ancient oral traditions. Multiple sources, redundant storage, distributed networks ensure information survives even if individual nodes fail. You accessing this video, sharing ideas in forums, discussing possibilities with others, this mirrors how ancient wisdom was transmitted person to person, story to story, generation to generation. The medium changed, the process remains. Consider how you found this content. Something drew you here. Maybe mainstream history felt incomplete. Maybe you sensed narratives didn't fully explain what you observed. That intuition wasn't random. It's part of humanity's collective process of remembering, where individuals drawn to ancient mysteries serve as nodes in a network recovering lost knowledge. You're not consuming fringe entertainment. You're participating in civilizational memory retrieval. This documentary exists in sleep storytelling format for specific reasons. Deep learning happens when conscious guards relax, when the analytical mind rests and intuitive knowing emerges. The hypnotic, repetitive narration isn't despite the depth of content, but because of it, ideas implanting in relaxed consciousness, where they can integrate without resistance. Your rational mind might dismiss some concepts presented here, but at the edge of sleep, information reaches places logic doesn't protect. This is how ancient knowledge was transmitted, through stories, through rhythm, through repetition, that bypassed critical filters and spoke directly to deeper knowing. Ancient builders didn't possess magic or alien technology. They possessed time, patience, observation, and willingness to work in harmony with natural principles. Modern civilization can reclaim that approach while retaining technological advances. The synthesis honors both ancient wisdom and contemporary innovation. You don't have to choose between past and future. You integrate them. This requires seeing the world with fresh eyes. Question what you've been taught. Honor the past while building the future. Recognize that monuments worldwide, symbols carved in stone, knowledge encoded in architecture and myth, all of it was preserved for moments exactly like this. When someone sits in darkness, listening to stories about what humanity once knew, you are that someone. The journey continues beyond this video, into your own research, your own practice, your own integration of ancient wisdom. What you do with this information matters. Whether you explore one concept further, whether you visit ancient sites with new perspective, whether you simply hold open the possibility that history is deeper and stranger than official narratives allow, all of it contributes. The monuments were built to survive any catastrophe, to preserve knowledge until the moment humanity would be ready to understand. That moment arrived. You're here, listening, questioning, remembering. The knowledge was never lost. It was waiting. And now it's waking up through people exactly like you, curious, open, willing to see what others miss. Welcome to the remembering.